Hello everyone, welcome to my second live stream. If you watched yesterday's live stream, we started creating a game in C from scratch. And I think it was great. The reception was really cool. I posted on YouTube. It's been less than a day. And already, we've seen a lot of people, like over 800 views in less than a day. That's a lot. And yeah, if you go to my YouTube page, youtube.com/danzaydan, you'll be able to see the previous episodes in case you haven't seen it. But I'm going to recap in the beginning of this live stream. Okay, so I created a itch.io page for the game where you can check out the source code for yesterday. So if you want to follow along at home, or if you want to, watch and play around the source code as the episodes go by, you can download it. So like here, just click download now. You're welcome to give a tip or anything like that here, but you can just download the source code. So I'm using episode 1's source code, and hopefully by the end of the day we're going to make some nice progress, and I'm going to post the second episode's source code here as well. Okay, so if you remember last time, we created our base platform layer and base engine, if we can call it that allows us to move, to render, to get input, to play around with the little square on the screen. Okay, so that was basically it. It was like 2.5 hours of work, and we got everything we need to start doing the gameplay. So that's what we're going to do now. We're going to actually build the game. And the idea is to start with a breakout clone, but slowly build more interesting gameplay as we have more ideas and things go fluidly. Okay, so I'm going to open 4Coder. Here's the editor that I'm using. And inside the code, there's the game code. So what we did last time was to create all these nice structures that we can use, like draw rect and pass a position, which is our unit here, and the half size and the color, as well as getting the input with these things. Now what we want to do now, I think the first step to create breakout, is to make the mouse cursor control the little square, not the keyboard. I think that's going to be more interesting gameplay, but we might change it later on, maybe do some different game modes and things like that. In order to do that, I'm going to open the Windows platform, and before we simulate the game, right after input, after the input messages, I'm going to call a function called getCursor pause for position, if I'm not mistaken. Let me just check it out. Okay, so yeah, this is the function we're going to use to get the mouse. But it's pretty weird because it returns this point structure. I'm going to call this a mouse pointer, and I get to a pointer of that. Okay, and but it returns in coordinates relative to the screen size, not exactly our window size. So what we want to do is to convert this unit that it returns to us to a window relative unit, like a screen to client. That's the function we need. And yeah, it's pretty easy. We're going to pass the window, and we're going to pass the pointer to the point, and then it's going to convert that to that specific window size. Okay. Yeah, okay. So a mouse pointer. Okay. Okay, that's it. Now all I have to do is pass that to the game. If you remember last time, we created this structure for input, and we already created this mouse X and mouse Y. I think inside math, I'm going to do integer vectors. We created floating point vectors for position last time. Now I think I'm going to do integers and call it like v2i, just so we can make like a more concise type here in the platform common. Okay, so it's going to be a v2i mouse, and for now it's in pixels. I think the game's going to be responsible to convert. We're going to check it out in a second. Okay, and if I'm not mistaken, the point structure, let me see, point, is just the x and y. Yeah, it's x and y, so we can pretty much use that. We're going to do a input.mouse dot x, right? Okay, equals mouse pointer dot x, and the same thing for y. Okay, and now we should be good to go. Okay, I'm going to debug, step into that, just to make sure that we didn't do anything wrong here. Okay, and now the input mouse has 200, 32, and 500. That looks like reasonable numbers. Okay, and now all we have to do, if you were to go to the game, you can now use that. But since it's in pixels right now, I'm going to use the draw rect in pixels. And I'm going to pass the input mouse.x, input mouse.y, and then I'm going to pass same thing, but I'm going to add like 20 to make a little square, and then I'm going to do red. Okay, let's see what we have. Okay, now if you can see, it's pretty weird, right? The X position is correct, but the Y position is inverted. Okay, and it's pretty easy to fix that. All we have to do here in the platform layer before we are going to process the mouse here. The Y is going to be, the negative of the what you get, but it's going to be offset by a whole screen height, as you guys can see, right? So what I'm going to do is to do height. So it's render buffer dot height. Yeah, minus, I think that's correct. Let's see. Okay. Now, the red square is sticking to our mouse pointer, and it's pretty, pretty precise. I think there's like a 1 frame of lag compared to the Windows actual mouse. So I think that's pretty good, at least for our first version, I'm not sure. But yeah, this is pretty nice. If you guys have any questions, you can drop them in the comment, in the chat, and I'm going to try to answer them. Okay, so now what we're going to do is create an actual player and have the user control the player. But we also have to convert that unit to world units. Let's call them that, because we're going to do collision stuff and things like that. And Pixel is not a very good unit, as we saw last time, because if you have like a very small screen, see that the green square that we programmed last time properly translates to the correct size based on this window, but the other one doesn't. So we're gonna have to change this mouse X and Y, mouse Y, to pixels from pixels to world. So I'm gonna call this mouse world coordinate, and maybe I'm gonna create a helper function in the render, I suppose, or math. I'm not sure, because we did the calculations to do the other thing, where we got a world coordinate and transform that to a pixel coordinate. So so all we have to do is the other way around. So let's do an internal. Let's return a v2, right? Internal v2. Let's call them pixels to world, and then I'm gonna get a v2i pixels coordinate. Okay, that looks good, and I'm gonna create a result here. Result.x and result.y. Okay, now let's think a little bit about it. Let me just do the simple call here. Pixels to world. Okay, I'm gonna pass input mouse. That's it. Okay, and now this we can pretty much delete. And now we're gonna do the same draw rect, but using the mouse world. Okay, mouse world. Okay, I'm gonna. Okay. Let's see. Okay. All right. Now let me draw, just to get a clear idea to you guys what we're gonna have to do. What we did in that other, let me hold it inside here for a comparison. On this function was, okay, we had a scale, which is a constant value, and then we chose, based on the aspect ratio, if we would use the height or the width as a multiplier to make it non-pixel dependent. Okay, so if you have like a very wide screen, we're going to get more size. If we make it larger, I suppose we're going to get more screen space, and it's not going to change the size. However, in this case, if you get a little bit of a wider monitor, this point's going to get larger. So that's why we multiply it like this. And then we just offset it by half the width and half the height, because we want to center in terms of world unit, at least for now, because we don't have a camera. Later on, we can do a more, we can get this as a parameter and then do an offset. Okay, so it's pretty much the same thing, but the other way around. So we are in pixels. So the first thing I'm going to do is to we're already doing that on float, correct? I'm not sure which point we should convert to float. Maybe right off the bat. Okay, so this guy is going to be a float of pixels coordinate.x minus half of the render buffer.width. Okay, and the same thing for y. I'm going to use height here. Okay, thank you. It says no question for the moment, but I like your stuff. I like it that you like my stuff. Hopefully we can learn a thing or two. If you have any questions, be sure to just tell me. Okay, so pixels coordinate. Okay, yeah. So that's the first step. We just offset it to the center. Now we should probably test it line by line. But I'm gonna write the whole thing, then we're gonna play around with it. Okay. Now we're going to change the aspect multiplier and the scale. The aspect multiplier is only changed once per frame. So later we can do like a cleanup of this. Only needs to be done when size changes. So maybe we can do that in the platform layer, or do like init render and do this calculation. But for now, I'm going to just create a function out of it. So I'm going to create a aspect multiplier, calculate aspect multiplier. Okay. And yeah, that's it. So the same thing I'm going to do here. I'm going to get the aspect multiplier. And now I'm going to, we are multiplying by it, I'm going to divide by it, and the scale. The scale, I'm going to do like a hard-coded note here just to make sure that we don't mess it up. Yeah, I'm not sure the best place to put this. Maybe as a global for now. Okay. Okay, now we did the first part. Now we're going to result.x and result.y. We're going to divide that by the aspect multiplier and the scale. So aspect multiplier and the scale, just the opposite of what we did last time. And okay, this is done then. And in this case, we have to do the half size too, but since we don't have a size here, just a coordinate or position, we have to do that. So I think we are done. Let me see what happens. Okay, and apparently we are done. And if you notice the difference, our world units use the center as the draw, our just here. Our draw rect, it gets the center and the half size, right? So now we are centered in the mouse. Before we were in the like bottom left corner because that's Windows coordinate system. Someone asked last time what was the coordinate system we were using. We're just copying Windows for now, bottom left in terms of pixels, and our coordinates like grow upwards in Y and to the right in X. So yeah, now we have pretty much everything we need to start making the game. This is what I'm going to do. I'm not going to pass. I'm going to, delete this green guy for now. Okay. Okay, and I'm going to do a vector2 here, and it's going to be the mouse world's x and a fixed y. Let's say 0 for now, just so we get the basic idea of the game. Okay, yeah. So this is the idea of the game. We're going to be stuck like this. Then we're going to move sideways. Maybe I should, limit the player's position, and then yeah, but not for now actually. Okay, so I'm going to do a little bit of a taller guy, like 2 and maybe 10. Let's see what we have. We got the other way around. It's 10 in X and 2 in Y. Okay. Okay, this is I'm not sure how good this is, but I think it will work for now. And I'm just going to make it a little bit down, maybe a little bit more. Okay. Okay, this is I'm gonna move him a little bit more downwards. Okay, this is good. Yeah, I think in terms of position, he may be a little bit too big. Not sure if it's gonna be easy or not. Let's test with that. Okay, so what we need now is a ball, right? So I'm going to create a ball P and a ball dP, which stands for the velocity of the ball, right? And I'm also going to initialize the variable, so it's going to be initialized. It's going to start as false, and the first time we run our loop initialize, we are going to set it to true, and then we're going to do everything we need to do to set up the variables like ball dp, let's say equals dp dot y equals minus 10 maybe. Okay. Now, okay. Now what we're gonna do is we can draw the ball, right? It's gonna be ball P. We're gonna make it v2. Let's say 2 by 2, and let's make it. I don't know. The colors are pretty bad now. We're gonna make it like this, okay? And then I'm going to calculate the ball P based on the ball dP, right? The ball P is going to be whatever the ball P was, so I'm going to make a mock-up here. It's going to be a ball P plus the ball dP times the dt that we get here. However, we can't do that. We can't overload plus to work on structs. So we're going to have to do our add v2 and multiply v2. Line v2, add v2. It's gonna get a v2a and a v2b. Okay, and it's going to return, let's say ax plus bx and ay plus by. Okay. Yeah, that's easy enough, right? Illegal force react. Now we're going to do our mole v2, and it's going to be multiplied by a scalar, correct? Then we can do like other kinds of vector multiplication later on, should we need them. Okay, this looks good. Now, so it's going to be add v2, and then this is a mole v2. Hello, Timmy. How are you doing? We are starting to get gameplay stuff. Okay, now this ball is not very interesting. First of all, it's huge, right? And it's falling very slowly. So let's make it like a lot faster, and if you can do like really small. Okay, now it's way too fast and way too small. 60 maybe? Yeah. Yeah, maybe that's okay for now. Let's make it start off kind of the opposite direction. Okay, yeah. That's still too fast. Okay. Yeah, now it's gonna work for now. Now what we're gonna do is collision, right? Because the ball is like just going through us. And I should probably, instead of mouse world, I'm gonna do this like player P. Player P. Yeah. And then player P. Okay. Now what we're gonna do is get It's going to test if the ball intersects with the player, right? And the basic idea for collision detection in this system is pretty easy. If you guys want to search more about it, it's called AABB versus AABB, which stands for Axis Aligned Bounding Box. Basically, we have a square and a rectangle, and they're aligned to our coordinate system. So it's not like a rotated rectangle or a more complex shape. It's very easy. So the only thing we have to test in order to see if they intersect or not is whether the biggest guy here is smaller, actually is larger than the smallest guy here. And the other way around, right? We have to be inside in both axes. Let me just show you guys what I mean. If, let's say, intersect, or we can call AABB versus AABB. Not sure if that's the best name for now. If the player P, and I also have to set the player P to -40, right? Player P dot x equals -40, and this is going to just change the player P x. Okay, so if the player P and players have size, right, collides with the ball P and the ball have size. Okay. Yeah, if it does collide, all we're going to do now, just for the sake of testing, we're going to redirect the ball dp. So ball dp dot y, we're going to invert the vector. So it goes up instead of going down. Okay, so that's the basic idea of what we're going to do. I don't know if AABB versus AABB is the best name, though. Okay. X is not a member. Okay, it's lowercase x. Player have size and ball have size. Yeah. Have size and player size. Ball have size. Gonna be a v2 of .75.75, and the player have size. It's gonna be 10 and 2. Okay. Yep. You can see the pattern emerging here. We'll implement libraries, box2d for example, or write everything by itself. Well, I may use libraries a little bit down the line, especially for like images and bitmaps. But I'm not going to use like box2d for a simple collision detection like this. We're not going to simulate physics or anything like that. It's going to be really, really simple. We can write this only function. That's the only function we need pretty much ever for a collision. And yeah, that should be enough for us to make our game. If we get to the point where we want more advanced stuff, and we're not going to, we can use library for that. But part of the idea is to learn a lot of stuff, so that's one of the goals. So I'm not afraid to try to write stuff that will be easier to get a library. It's also fun to write this sort of stuff. Okay, player P. Okay. AABB. Okay, so now we should, I'm not sure if we keep that a math or we create a new collision.c file, but it's going to be pretty small. So I'm going to inline a bool 32 called AABB versus ABB. It takes a P1, a half size one, and then everything again instead of 1, 2. Yeah, that's it. And this is what we're going to return. Let me just draw it a little bit more complex. This guy, let's say, does not intersect with this guy. How do we know? We know that because the largest guy is smaller than this guy. See? And in this case, where the largest guy is bigger than this guy, the smallest guy is smaller than the biggest guy. So it kind of works the other way around. See? So I may do each point individually just for the sake of clarifying. Maybe in the optimized build it's going to be, yeah, I think I may do that. I'm going to do like 1x0 to get this point. let's see, I'm not sure, may not need that. Okay, so p1.x minus half size 1 dot x. So this is this point. That's it. If this guy is greater, if just see a failure. If this guy is greater, we add do subtract. If this guy is smaller than the largest guy, right? But p2 and I have to do this for pretty much every other combination, okay? And this guy is less than this guy. Okay, I'm not sure this is correct. We're gonna test just in we should test just in x for now. I'm sorry. We should test just in y just to see. Because the basic idea, I think we're gonna do a more simpler version. Just to get started. If let's say it's a 1D collision, right? We have our P1 is the player, right? The P1 dot y plus half size 1 dot y is this point. Let's say the player like this. Okay, so this point is the one that we're testing. If this ball, which is this point of the ball, which is the P2 dot y minus half size 2 dot y, if this guy is smaller, right? Or we can do it the other way. If this guy is smaller than this guy, there's no collision, right? So we have to test if it's greater than this guy. So this is the very basic one, and I think we can do that. Okay, all I have to do is include. Should probably include that in the game because it's like engine stuff. But for now, let's just include here. So we should just kick, right? Yeah, okay. For some reason, it started offset. I'm not sure why. Let me just see. I think we set the game. We should have set the py to minus 30. dpx to 40. Why did we do that? I think I meant the py to 40. Yeah, I think that was it. Yeah, this is it. So see what we did there? We finished we didn't finish. We started a 1D collision. So whenever the ball hits this part of the player, yeah, it just reflects. Now the problem is that we don't test the x coordinate, right? So we can just move by the side anyways. See, it's easier to do this step by step. So the same idea for the x. Okay. So if px plus half size 1x is greater than p2x minus half size 1 dot x. Now we're testing if it's in the right side of this guy. So right here, see, it passed through nicely. But right here is going to reflect because we're not testing this size yet, okay? You guys understand, right, the process of making this thing? That was pretty... When I started typing this code right off the bat, it started to get complicated, even in my head, even drawing a little bit. So just did the simplest thing possible, and we managed to fix that pretty easily. So yeah, let's say like this. Okay, works. Now let's say this side doesn't work. Let's do the other side. Now the question for you guys is, what happens if if the ball is like gonna pass me and then I intersect with this like this? Let me just try a more visual thing. Pretty much every frame, right? Sorry, I didn't get it right. Every frame you should. Yeah, it doesn't shoot up. See that it's stuck? If you see, I managed to catch it in the perfect position. If you see very closely, you can see that it's actually going up and down every other frame. Yeah, it's pretty weird, right? This is what happened. We're testing. If we are colliding with a ball, change the direction. So this is what happens. We are here, and the ball is here, right? We're not colliding. We're not colliding. Let's say like this. Now we are colliding with the ball. So it was going down. Now it goes up. But in the next frame, we are still colliding. So we change the direction again. See, and that's basically infinite, right? So there are a few ways we can. Yeah, it does make sense, but it's weird, right? It's kind of counterintuitive a little bit. What we want to do is maybe a little bit of a hard-coded solution, right? Is that maybe we should test if the we can test a lot of stuff. We can do like if the ball is less than our position, right? Which means that the first collision happens. We just change the position, and then we don't test like something like this. If the ball p dot phi is smaller than -1, smaller than 0, we test the collision. See, so now we only test if the ball is coming toward us. So if the ball is like this, the dp is negative, we're going to test the collision. And then we test the collision like this, we collide it. Then all it's going to do is to reverse the direction, but next frame, since it's going up, we're not going to test again. And let's see if it works. See? Now, I'm not sure if that's the best call to do in terms of game design. I'm not sure how it feels either. But for now, I'm just going to ignore that and kind of work the way it is right now. Okay, but it's not a very interesting game if you can't change the direction of the ball, right? So that's a very basic thing. We could, just to get started, if we collide, we change the direction of the phi, and we add the direction, we add the x direction, right, to the player, but we don't have the player speed. So I'm going to assume that we have a player dp and dot x, correct? Yes. And so the idea of this movement, and we're going to iterate that a lot in terms of design. If we are going really fast this way, let me draw. It's going to be easier. This way, and the ball hits us like this. Let's say like this. It's going to go this way. But if it's already going this way, all we're going to do is to add our position to it. So it may go straight, like a tennis effect, like the ball is really affected, and you get the other effect. So kind of a one counters the other one, and then you have the straight movement. Or yeah, if you go to this side, it's going to be way faster, right? Or if you go like a very tiny amount, maybe all we can do is remove a little bit of the speed. I think it's going to feel nice. But we do have to get the player dp, which is the player velocity. And all we're going to do is to subtract the old position. I'm going to call call this a player new x. Okay, player new x is going to be this. And the player dp dot x, is going to be the old x, which is this guy, minus the new x. Player new x. Okay, hopefully that makes sense. Let's see if we're going to move a little bit like this. I think we got the other way around. Yeah. Yeah, we moved to the other side, and that was pretty slowly. So this unit is the player dp. Oh, the player dp is in seconds, and this guy is in frames. So we do have to multiply this by the dt. Isn't that correct? So let's say we are at unit 10 and now we're at unit 12. I'm sorry, the other way around, like decreasing, like now we're unit 8. Our DP is the new one minus the old one. Okay, so we fixed that direction problem. So it's going to be -2, right? But this -2 is -2 per frame. And we want this scale to be per second. So how are we going to change this? All we have to do is, let's see, just do this, -2 per frame. And we have to do a per second thing. So our DT is how many seconds per frame we have. Yeah, so if we divide by the DT, correct, we're going to multiply by this guy. And then we can, yeah. Okay, let's see if that is correct. Okay, yeah, now we're talking. Huh. I think it's a little bit too sensitive. I'm just trying to do. Yeah, look at that ball go, Tini says. That was pretty interesting. Yeah, I think it's let me just do like this. Yeah, I think it's nice. Maybe it's gonna be hard to do like a very precise ones. Then we can make it not exactly like this. Maybe we can add like a loss of energy, arbitrary here. But let's see. Now what we're gonna do to make it very chaotic, and I think it's gonna be fun really quickly. All I have to do is to make it bounce off the walls. That was really, oh my god, it's gonna be funny. Yeah. It's going to be really chaotic. Okay, so the same thing we did for the player, this idea here, we can do for the ball. And just as a final example, I'm going to do the other x, other y as well. So this is actually the AABB versus AABB because we're missing one axis here. I think that's correct. In this case, not going to make much difference unless, you know, the ball is like here and we went past it. But yeah, just to make it complete. Now, if the ball collides with the player, okay. Else if the ball P dot x is greater than, and I'm going to get like an arena half size, just for us to have that easily measured and maybe display a little bit of a difference. If the ball x is greater than the arena size dot x, all we have to do, and we should probably also cap the ball position, maybe, possibly, like, if the ball went like this, we should just make it like this and then change the direction. If you want to do like a more precise collision detection, we should make it move just minus the part that it already moved, that frame, if that makes sense. But for now, we can comment this and make like a robustness comment, like yeah, subtract what the ball already. I don't think we're gonna care about that much already. Yeah, I am going to comment that. Subtract what the ball already moved to get to the colliding position. Yeah, but I don't think we're gonna care about that much. All we're gonna do is to set it back to the arena size x. And actually, this is not correct. Just like here, we did a plus half size, have to do that as well. So we're testing if it's greater than this side of the wall, right? So plus the ball half size dot x. Okay, if that is greater than the arena wall, then the ball x is going to be the arena wall minus the ball half size. Hopefully that makes sense. If you guys have any questions, you can ask. But that's not very difficult. And we're going to reflect the vector. So ball p dot x, right? Okay. Arena, yeah, and now we're gonna have to create the arena size. Arena half size. Yeah, I called it area half size. Arena half size. going to init that to, let's say, if the player is at minus 40, maybe the arena, that's an X, maybe the arena is like 50. Yeah, we have to draw that as well. Let's say it's 30, 50, actually 80, 50. And then we're going to draw a rect for the arena. And then we can optimize that later on, because I had this problem in the Pong game that I showed you guys last time. If we have our screen and then we clear it to a color, so we're going to go to every pixel and draw it. And after that, we draw an arena on top of that. Let's say blue. We're going to waste a lot of work, filling those pixels. So what we should have is like a clear screen and fill rect, single function. So we clear the screen where the rect didn't, appear, let's say. But for now, let's just do 2 calls. So we're going to do it's going to be vector2, 0, 0. We're going to do player, not player, arena half size. Arena half size, okay. Now let's see what we have. I'm also going to do that in the other direction, just so we can properly test. If it's less than minus arena half size, okay, the position is going to be this guy plus, yeah, minus arena half size plus this guy, and then we're going to reflect the X as well. Let's see. Okay, green was not a very nice color for the arena. Let's do it like a slider. Let's make this a little bit darker. And let's make this one the previous color. Okay. I turned out blue, but that's okay, I suppose. Wow, did I really miss that? Let's see. You got it wrong, apparently. This guy. Minus half size plus ball half size. Oh, it's DP. Yeah. That was weird. Okay. Now all we have to do is the same thing for the white, but the arena didn't. It's not very nice. I think it's okay in terms of X, maybe a little bit more. Maybe we're gonna do 90, but we can make it like shorter, like 45. It's gonna be great. Oh, now we got a little bit too much here. 85, 85, 45. Let's see. Okay, yeah. Yeah, now we're talking, right? It's gonna be really hard. I have to really multiply this guy down. Okay, and then we're gonna test the same thing for the top position, but I'm not going to put that in the else if, because maybe in one frame it can do like both, like this. So I am going to do a separate if for that. If ball p dot y is greater than the arena half size dot y, I'm going to do the same thing, plus ball half size dot y. Well, in this case, we're going to do the same thing, but for y. So it's going to be plus this guy minus this guy, and you're going to reflect the y position. Yeah. Now we're starting to have the basic gameplay idea. Okay, yeah. Let's see. Okay, let's see if I can try to get that ball. No. So yeah, I'm going to put like a random number here, just because that was really hard. Let's see, this guy. I'm going to comment like this. Let's see. Yeah. Player collision with ball. Okay, and let's say half of the force that I have. Okay. That was a little bit better. Yeah, see what happened? You saw the ball inside me? That because it entered through the side. And yeah, maybe, just gonna test to see how that feels. Maybe I'm gonna do the ball P dot X is going to be the player P dot X dot Y, I'm sorry, typing correctly and saying incorrectly, plus the player half size dot Y. So now if we do that and to the side, it's going to, yeah, I think that feels a little bit better. It's going to automatically go to our position. Okay. Yeah. All right. See, we're not running very nicely when we go to full screen. That's because the build is not optimized. And it's because of this as well. So maybe we can do that really quickly in the software rendering. We're going to do a clear screen, and draw rect. Okay, this is an internal void. And the basic idea is it's going to work like a normal draw rect, but where there's not a rectangle, we're going to get a clear color. So yeah, pretty easy stuff. Convert, we already did that convert. Okay. So yeah, same thing, apparently, right? But we're going to draw 4 more rects where we don't, where we are not in terms of the rect position, right? So if we want to draw this rect, we're going to draw it. That's this first line. But now we have to draw this rect, this rect, this rect, and this rect. Okay, oh, you guys didn't see that. Okay, have to draw this guy, and these guys. Okay, so the first one is going to be 0, right, which is the first pixel, and 0 to the y, and it's going to end in the x0 and y0. So it's this guy right here. We're going to start here and go all the way to x0 and y0. I'm sorry, it's not going to be y0, it's going to be all the way to the top. So it's going to be the render buffer dot height. See, it's nice to draw sometimes. Okay, so that's the first one. The other one is going to be the same thing, but instead of starting at 0 and ending at x0, I'm going to start at, and I'm going to pass clear color. I'm going to start at x1 and end at a render buffer width. Okay, so now we got this guy. Started here and got all the way to here. Now the other two that are missing, they start, the x is x0 and x1, and the y is 0, y0, y1. It's pretty much the same thing, but instead of going all the way from 0 to here, we can do just the offset because we already painted this part. Okay, so yeah, let's see. So it's going to be, it's going to be x0, x1. And let's see, the first one is y0. Let's say the first one is 0, y0. And the other one is going to be y1. And draw buffer dot height. Dude, you're my last hope. Let's see. I stumbled on something. Send me this code. He said they are recruiting. They said like 20 things to do. You would have no idea what you're talking about. I'm sorry. Yeah, I also have no clue what to do. It's got a random streams of numbers. Yeah, okay, apparently so, TV. Okay, too few arguments. It's not the draw rect, it's the render buffer. Dot height. Okay. Okay. So maybe if you go full screen, we're running a little bit better, but I'm not really gonna care too much about it for now. Okay. And I have this light impression that our screen size doesn't consider this guy. That's why we're not actually properly centered. I'm not entirely sure. Yeah, we're not 100% centered, and that's not very nice. I have to check that later. I think it's in the conversion. We're probably doing something wrong here in software rendering. We multiply, we change the scale, right? And then we change the width and height. Now that does look right. Yeah, I'm not going to spend too much time with this right now, because all we're gonna do is some gameplay. Hey man, how are you doing? Hopefully you can get along pretty well. I know you know all that stuff, right? And we are in the gameplay part, so this is gonna be the more fun part. So this is what we have so far. I'm sorry, I just lost. We control this guy with a mouse, and there's a ball, and we just finished Collision, the first version of Collision. And we can like control the direction of the ball. And things like, it's not very nice to control yet. It's kind of a little bit weird. But I'm gonna give us a goal in order to test that. So now we're going to start with the actual objective of the game, right? Which is to destroy the blocks. See this pattern here? We got the P, the D, P, and half size. This we could probably create a struct and base this guys off it, like an entity struct, something like that. But I'm not gonna do that for now. Maybe a little bit later, because I think the block's more important because there's gonna be a lot more blocks. So what we are going to do is create a struct for the blocks. Yeah, that makes sense. Block, and for now it's gonna be just a P, and let's say exists, or maybe life. Yeah, let's say life. And what I'm going to do is just going to create a bunch of blocks in the stack here. Let's say we're creating 64 blocks, and in the initialization, I'm going to display these blocks somewhere. Okay, maybe we should also put a block size here. So, we're going to go through all the blocks. Well, not all the. Let's say we want 4 blocks, 4 by 4. So yeah, I'm going to do a Y block and a X block. Okay. Okay, and we're also going to do a nice trick that says the next block, which starts off with as being 0. So all I'm going to do here is to get a block, which is the blocks plus next block, and we can assert. We don't have a assert. Are you doing my homework? Breakout? No, your homework's not going to be breakout. It's going to be a more complicated game. So yeah, consider this not your homework. We can assert that the next block is less than the. Well, in fact, I'm not going to assert that. If the next block is greater or equal to the array count, we're going to create that as well. The array count. Do you remember how to do the array count? Tell me in the chat if you do, and then we can do that piece of code. the array count of the blocks. And okay, then the next one is going to be 0. So we're just going to ignore and start reusing the blocks. Now, the array count, let's just put that on the utilities. I'm going to do a macro. It's going to get the array, and the macro is going to be pretty simple. It's going to get the size of the array divided by the size of the array's first element. I think that's correct. Okay. So yeah, it's basically going to give me the size, the size of the array. Like, let's say if the array is a 10 elements, then it's 4 bytes per element. The array size is 40, and the element is 4. So if we divide those guys, we have 10, right? That's basically the array size. It's pretty easy. Now, then we're going to do block life equals 1 for now. And we're going to do block p dot x equals, let's say, x times blocks. I think the block size is going to be a constant here for now. Block size. X times the block size x plus, let's say plus nothing. Just going to be this base offset. And the y is going to be the same thing for the y. Okay, and then all I have to do is to initialize the block size. Block size is going to be this guy. Let's say it's 2 by 1 for now. Okay. Yeah, we also have to render them, I suppose, right? So this is the. Oh, we didn't use actually. I kind of lied when I said it was faster. We didn't use the clear screen and draw rect. So I'm not sure why I felt that was faster. Maybe I don't know. Okay. Okay. Now it should be a little bit faster. And actually not a little bit, like twice as fast, honestly. Yeah, now it's good. And the colors changed for some reason. Okay, now we're going to render all the blocks for block equals blocks not blocks plus array count blocks block plus if there's no life. I'm going to continue. What graphics library are you using? We're not using any graphics library. Forgetful. In case you're forgetting, past stream, which was the first stream, we created this basic setup. We created the window. Let me just show you. We created the basic window here. We created the message loop for input, and then we created these functions to just draw the pixels. So we're doing software rendering with no graphics library. If you want to check that out, it's on YouTube. The recording here. I'm gonna paste that on chat. It's youtube.com/danzaydan, and you can watch the first stream. It's like two hours, and we do that. It's pretty cool. Okay. Just arrived, so no idea what's going on. Yeah, it's okay. We're making a game in C from scratch. So last stream, we started with literally a blank file. We started typing crazy things, like crazy, not crazy things, just code. And then we did the first part, which was the basic structure we needed, which was the window, the input, the software rendering, pretty much. And now we're doing the gameplay. So yeah, we're kind of slow, but we're getting there. So now it kind of moves. Now we're gonna do the block rendering. Hopefully, we're gonna see the blocks. We're going to draw the blocks, and it's gonna be block p block half size And the colors are really bad for some reason. Let's do green. We already have a green. The player. Yeah. Oh, we're gonna do a nice color pass later on, but not now. Okay, block half size and block half size. Okay, let's see if we have some blocks. We do have. Not sure this is correct though, but we do have some blocks. Okay. Not exactly sure if that's correct. Let's do one block. Should be one block at 0, 0. Yeah, I'm sorry, I have to. One block. Okay. Yeah, so I guess that was correct. You know what I should do? Each block should be a little different in terms of color. Just to start making it more interesting. Yeah, I'm going to do that. I'm going to do a life and a U8 color. And here, we're going to set the block color to, let's do a shade of gray based on these guys. So I'm going to create in the math, let's do like color helper functions. We're going to do a make color from gray. I'm not sure this is the best name. Gray. And all we have to do, remember we have 32 bits of color, and we're receiving 8 bits of a gray color. You want to put that on every channel. Let's say the 3 channels, the 3 color channels. So we have to shift the gray by nothing, which is the blue, right? So we're going to shift by nothing. And we're going to end that with some other shifts. We're going to shift that 8 bits to get to the blue channel and 16 bits to get to the red channel. Okay, so it's going to be make color from gray. Let's just do x plus y for now. And let's do more blocks. Let's do like 10 blocks. And maybe x plus y times 2. Then we can do some pretty interesting things with this later on. Okay, so I do have to use the color though. And that position was all messed up. Okay, so block color. Okay, now this is pretty cool. Can you guys see that? But it's wrong. It's cool, but it's wrong. Yeah. I'm not sure what else to say. Have to run through the code to see. We're creating 10 blocks. And the x is the x times, well, yeah, because the half block, I have to make it times 2. Okay. Okay. We are better, but we're still wrong. Because for some reason, this row is not being used. Y plus plus, x plus plus. Not sure. Let's do a little bit slower. We're going to do one row of 10 guys. Okay, that looks correct. 1, 2, 3, 4, 5, 6. Yeah, looks correct, I think. And let's do 10 rows of one guy. Okay, that also looks correct. Now I'm not sure why making 10 rows of 10 guys is wrong. Oh, maybe we don't have enough guys. We don't. We have 64. So yeah, we decided not to crash and just to reuse the same guys. Well, that's what happens, right? So I'm going to make it like a 256 guys. Okay. Now we're going to have some fun, right? Let's make them a little bit bigger just for the sake of entertainment. Okay, let's make it like twice as big. Okay, nice. And now let's also offset the position. So instead of them starting in the center, let's do like a number of y guys, let's say 10, number of x guys 10, num y, num x. Okay, and then we're going to do a x offset, and the x offset is going to be half the size, right? Block half size times the number of blocks, num x dot x and dot y. Okay, that's basically it. So if we add these guys, we should be all good to go. X offset and y offset. Yeah, but we did it wrong where I have to subtract. Oh, that was not good enough. Okay, now it's pretty nice. But the y, we shouldn't center that. We should probably, I'm going to hard code it for now. Plus, let's see, plus 30. Then we can think about that later on. I'm sorry, minus 30. Getting it all wrong now. Too much. Okay, nice. Yeah, and that's going to be it. Very nice. Okay, let's start colliding with the blocks. Then I'm going to focus on making the gameplay fun, right? But pretty easy. We're going through all the blocks here. Not sure if we should do that twice. At which point should we do that? Maybe we should do... yeah, we should probably do here. But we already cleaned the screen and draw direct. For now, we're going to do inside the rendering loop. We're going to simulate and render these guys. And yeah, it's going to be good, I think. So we're going to do the AABB versus AABB that we drew earlier today. If we are colliding, so this is going to be the block P, block half size ball P. Okay, if we do collide, we have to know where we collided from, right? So maybe we should do a block versus ball operation. Yeah, I think that's going to be better than trying to, or we could just pass what direction we collided. Let's see if the collision. Nah, I think I'm gonna do a let's say do block versus ball collision. I'm going to receive a block pointer and the ball P and the ball half size. And we're going to separate these two axes here. Because if we are colliding, we have to know where we're colliding from, right? If it's up or down. I mean, sorry, if it's this side or this side. Like we have to know if the ball came this way to deflect this way, or if the ball came this way to deflect this way. See? So I think the best way to do that is just going to be, yeah, if we do collide, we have to check which axis is that. So yeah, I'm going to do the first thing here and to call collide y and collide x. So if we collide them both, now you can see which one we are colliding, right? Makes sense? If we collide x, I'm sorry, this is collide y. And then if we collide x, same thing. If we do collide x, else collide y, we should probably worry about both too. So we do a if. Okay, and we're going to do the same thing we do for the arena. Right, I'm just going to change the direction. But oh, actually, it depends, right? So if we collide, we're going to decrease the block life. No, we're going to change direction either way. So yeah, if we collide in the x, let's just change the direction. I think it's not going to work in the same case that we had to work for the player, like this case, where it's inside the block and it wants to leave, but in the next frame couldn't leave. So in this case, I think it's going to be just change directions. So we have to know exactly if it's this side, so we can move him, or this side. Yeah, so I'm going to split that even further. Yeah, I'm going to do collide y. Let's call them left, which is this guy. Collide y left. It's going to be easy to see, but it's going to be a little bit repetitive in terms of what we do. Let's say plus half size greater than p2 minus. And instead of p1 and p2, we have to change the block to the name to block. Okay, so we're going to change y to x. Okay, and okay, if collide y left, right, and collide y right, and collide x right, left, and collide x right. And if we do the x right, we're going to, now we're in the same point, we're going to change the ball dp to the other x and the ball p. The ball p is going to be the block p. If you collide with the right side of the block, yeah, it's going to be plus block half size. So I have to get that. Size. Okay, that's okay. That does look good. And now we can test the dy collide here. I'm sorry, the y is up and down, right? If it's minus, it's down. It's plus, it's up. Okay. Sorry about that. Down. Okay. If we collide with the right, that's what we do. Else, we're going to see if we collide with the left. Hello, Morpheus. Let's see you again. Let me show you what we did so far today. We are starting to look like a game. So we can, oh, that was very stupid. We have a ball and we control the pedal with the mouse and we can move and it collides with walls and stuff. Now we're doing the block collision. Okay. Hey Marcus, thanks. Just like congratulations for your initiative. Thank you very much. I hope you guys enjoyed this as well. It's going to be a lot of fun. And yeah, we're almost done with the prototype, and that's the fun thing. We're going to do the breakout clone. It's going to be the first thing. But we are going to start playing around with it in terms of game design and make it more complicated and interesting things. So I expect to spend some time in the gameplay for now. But yeah, in terms of the game, the base game, it's almost done. It's not that much work, you know. See, that's the thing. People usually think that making game. Oh no, I'm talking about simple games, right? Making these simple games from scratch are like impossible, or like really hard. It's really not it. We spent like one day, which was like 2.5 hours, doing the engine. Now we're doing the gameplay, and really not that hard. So if we collide with the upside and now collide with the downside, I'm not sure this is entirely correct. Just going to run through this one more time. P1, yeah, I'm going to change P1. P1 is going to be block P, and P2 is going to be ball P. And half size 1 is going to be block half size, and half size 2, half-life 2 is going to be ball half-life. Ball half-life. Oh, I actually typed ball half-life. It's supposed to be ball half-size. Okay, so half size 2 is going to be ball half-size. Illegal for struct. Block P. This one's block Y. Okay, syntax error. Missing semicolon. Where are we missing a semicolon? Okay, yeah, else if. It's weird. We didn't miss the semicolon, we missed the if. Will you save the videos? Yes, I am saving the videos, and the first one is already on YouTube. If you go to this link, which is my YouTube page, it's youtube.com/danzaydan. The first one's already there, and it answered the other guy's question. I remember who it was who answered how we did the rendering. We did it on the first episode. That was pretty easy. No problem, Marcos. I hope you enjoyed it. If you have any question about the previous day, you can also ask me. And the source code, if you want to play around with that, is available on the HIO page. So right here, which is, you can copy the links, danzaydan.h.io. There's my game there. I'm calling it Break Arcade Games Out. It's a very bad name, but hopefully it'll hint of the gameplay ideas that I have for the Breakout game. I already put the first day's, well, there's not a game, so the executive is pretty boring, but I do have the source code there, all 4 kilobytes of it, right? And so if you can download the source code and follow along, or if you want to do your own game, that's pretty cool. I'd love to see that. And not gonna spoil the surprise, but hopefully I think we're gonna have a forum too. So yeah, just click download now. If you don't want to, if you don't don't want to tip me, you can just click no thanks, and then you can download the files. Yeah, easy as that. Okay, let's go back to the, yeah, we compiled. Hopefully that was it, and now we can start doing some collision. I think, oh, we're not calling that. And we spawn the ball inside the guys, so it's not going to be very good for that. So all I'm going to do, I'm going to spawn the ball a little bit to the side. The size of the arena is 84, 85, so I'm going to spawn like 70 in X for now, just so you know we can do that. Okay, yeah, it's kind of cool. Now we're going to call these guys. Instead of calling the AABB, I'm going to do the, let's see, do block versus ball collision. I'm going to pass a pointer to the block half size, ball P, and ball half size. Okay, redefinition basic different types. Okay, because we, yeah, I think in the Windows platform, the problem is we are first using the function and then we're declaring it. And C has this, in C++ too, has this for declaration thing, which is like from before I was born. And yeah, I'm gonna actually import the collision here. Okay. Let's see. Missing. Yeah, I actually have to declare the block and things. Yeah. Okay, now we compile. Let's see what happens if we try to run. Oh my god. I don't think I'm gonna keep the mouse control. Either I'm really bad at this or it sucks, right? Okay, just reflected off these guys, but it's kind of weird. I think I just messed that up the x and y. If let's see, the x, yeah, it's the other way around. If you're testing the y collision, just draw for you guys. Let's say this is the block and this is the ball. If this fails, so we are inside the x position, we have to kick him off the y position. See? So that was the problem. I think, let's say, I think I'm going to just change these guys. I say x, yeah. Yes, if we are past, let's say, the y is less than this guy. So if we collide in this part, yeah, we might have to review that. For now, let's just see what happens. Let's just call this left and right, just for the sake of seeing the result, and then I have to do some cleanup. Yeah, let's see what happens. Yeah, it's not right. Yeah. It's funny. It's like nothing changed. But we changed the y to be based off the x. Okay, I'm a little bit confused now. Yeah, what I'm going to do is switch these guys. Okay. What is ball P and ball DP? Ball P is the ball position. So we initialize that 7540, and every frame we calculate the new position based on the old position. So we add the old position, and we multiply the velocity with the delta time. So the D stands for I'm not going to be able to pronounce that. So there's the integration and the derivative. I think that's how you say it, derivative of the position, which is the velocity. So yeah, I think it's easy to call it ball v. And if you want to do like acceleration, we go ddp. I think that makes sense. Yeah, it's pretty cool. Okay. Now it changed pretty much the whole thing. Yeah, I think it's correct now. Except well, the x was kind of correct, except we did deflect the y. Oh, so the problem is we're deflecting both the y and the x, and we should only deflect the x. Maybe it's because, yeah, this calculation is not correct. We're going to have to do this a little bit more slowly. Okay, so this is what we're trying to do. The block and the ball. We already have the AABB versus ABB, which test collisions with two axis aligned bounding boxes. In this case, it works perfectly. But we need to know if the collision was done in this side, like this, or this side, or like a corner here. And either way, what we are testing if one is inside the other one, right? Okay. All you have to do is, yeah, we can do like a cheat and say, yeah, I think I'm going to do that. It's going to be cleaner. Yeah, the cheat is if we collide, I'm going to do the ABB versus ABB. Block P, half size, block half size. Ball P, ball half size. Okay, yeah. If we collide, we are inside one another. And I can pretty much test, well, if our P is less than their P, I mean the ball P. If the ball P Y is less than the block P Y, that means we should reflect downwards. Well, not really. Because in the case that we kick off this side, yeah, I should probably study collision more deeply. So yeah, so now is where the learning thing comes in, because clearly there's a quicker solution to that than that I'm thinking, and that box 2D guy in the beginning of the stream, I guess he was right. I can kind of accept that. Not that we should use a library for that, just because we want to learn. The point is we should learn it more thoroughly in terms of collision. The idea of collision is really simple. If we are inside this guy, all these things are true. So that first thing was really wrong in terms of the collision part. Now, the point is, we are inside. How do we know if we should reflect this vector, this vector, this vector, or this vector? We could hack something together like, oh, if we are really close here, but if the ball is really fast, and it kind of collects like this, it should reflect really downwards. So yeah, I guess the point is we should just change the based on the ball speed like we did here. In the player, for guys who weren't here in the beginning of the stream, we test if the ball is going downwards, then we test the player. Yeah, I'm going to remove that commentary just because no one cares for now. Yeah, that kind of makes sense. If the ball is going upwards, reflects it downwards. And if it's going right, I guess we just do both axes all the time? Maybe. Let's see what happens. Not sure though. Let's see. If you hit the bottom of a block, you just revert the Y. Yeah. Yes, that's the point. Yeah, we can't do that. Because if we are in the bottom, we are not going to revert the other one. You are correct. But the problem is, how do we know if we hit the bottom of the block? See, because our collision tests if we are inside the block, right? True or false. That's what it returns us. So the question is, we are inside the ball, the block, right? We can get the position, but the direction, yeah, but the direction is not going to give us much. In this case, we only want to reflect the Y, not the X. So if you want to really hack this, just for the sake of seeing the correct result, even not for all the cases, this is what we expect. Just like you said, we're just going to revert the Y. See, now this is correct. Now the problem is, if we do like this, see, if we hit this part of the block, we should revert the X. Question is, how do we know where we are inside the block? There should probably be like a linear algebra solution to that I don't know off the top of my head. But yeah, we can test if we are like on this. Geez, I may have to search that, and it may not be fun to go through all that stuff. Let's see. Yeah. Yeah, that's what happens when I go just do one axis. Okay. What happens if depends on the frame rate and ball speed? Yeah, but if I use the ball speed to determine where I'm going to kick off of, I don't know. Like maybe I should. Yeah, I should probably subtract it. I think that's the point. I have to subtract the two factors. This is the problem. If I use, let's say the ball speed is going like this way. Let me just try. Okay, it's going this way. The ball can pierce the block through a slope. That's true, but we're not going to have such small blocks that, yeah, I also agree that's unlikely to happen. Yeah, it's called tunneling, what you mean, and we can probably fix that by kind of a sweeping. It's the collision term, sweep these positions. And that's probably what we should do anyways. But the problem is, in terms of the DP, is that that DP could be the same here, right? So it doesn't really matter. What we do want to test, like if we are, if we are inside, because this we are inside all the points, yeah. Yeah, what we can do though is subtract, is to get the, you know what, I think I'm gonna have to search that and play around with this some more. Because I'm not entirely sure of the formula that we should use in this case. Like, yeah, I'm gonna do like a quick search here with you guys. But if I fail, I may search off stream. Let's say, let's do AABB versus AABB. Let's see what people say about that. If the ball is completely inside the block, you have no way to know the ball direction. I do know the ball direction, but the ball direction, as I wrote that, as I drew that on as a red arrow here, the ball direction can be the same, but I'm going to interpret that differently. So in this case, I'm going to revert just the x and keep going up. In this case, I'm going to keep going to the left, but I'm going to revert the y. So yeah, I do know the ball direction, but I don't know how to use that to give me the answer, because see, in all three cases, the direction is the same. And we can't do like a very hardcore thing of knowing if we are, to this side or down here, because we may reflect like this. In this case, we should only reflect upwards. You know what we can do? Yeah, I think that's going to be a reasonable solution. We're going to look in the old position. Do we have the old position of the ball? Yeah, we can get the old position. Okay, so we try to go here with the ball. If we can't, we test if this y, let's talk about y here. If this y is less than this guy, and if this guy is more, let's call this old y. If old y is less than this guy, and if y is greater than the other guy, then we can deflect y. Does that make sense to you guys? Let me try to open the window here just to get a little bit more wind. Okay. Yeah, you know what? I'm going to do that. I'm going to get the old ball P, and then play around with that. It's going to be kind of a hack at first. Not really. Okay, so let's try this one more time to see if it's gonna work. So we have the block and we have the ball. Then you will need to reflect x. Exactly. In this case, we would reflect no. If we would reflect y in this case. So in this case, I mean, I pointed with my finger. I have to point with the mouse. In this case, we should reflect a y because it's going to keep going to the left in terms of x velocity, but the y is going to change. It's going to go downward instead of upwards. So what I'm going to do is when I collide, like I'm insiding somewhere like this. What I'm going to test is, well, I can do that with the dp, so I don't need to. Yeah, I don't need to save the old p. No, I'm sorry. Yeah, I could do that with dp and go backwards. But I think I'm going to save the old p anyway. So we have, let's say, this is the old position, old p, and this is the new p. New p. Okay. We can kind of hard-codedly test, nice term, test if in, the x and the y and all the x's, if this guy is in the one side of the x guy, and this guy, I'm sorry, of the y wall, let's call it that, and this guy is in the other side of the y wall. Correct? I think so. Or maybe we can simplify that. Maybe we can simplify this guy too. If we test the wall individually, which is like if the, let's say if the new p dot y, if the y, yeah, this is the sweep we were talking about earlier when you asked about tunneling. That's kind of the way we're going to do sweep with the direction. So we're kind of doing a fake sweep for now, just because it's not very clear to me how to do a more robust thing. But yeah, I think we're going to hack that now, and then we can clean it up as we see it working. Okay, so I'm going to have the old ball P. Okay, so let's do old ball P equals ball P. And here, I'm going to pass the old ball P to old ball P to here. Old ball P. Now, if we are inside the block, I'm going to test. For now, I'm just going to test this guy, and then we can test these guys later on. Okay, and that's assuming the blocks are static, which they may not be. Okay, if the x is less than if the old x, old ball p dot y, if the y is less than, let's say, the block py minus the half block half size y. So if this guy was in here, we already know for a fact that we can reflect a y because it entered this. It may have entered like this. In this case, we should reflect both. But in this case, we can pretty safely reflect it. So yeah, so it's going to be, since this is a global for now, we can just use it, but later we're going to do it more. Yeah, these problems are pretty interesting. That's why I don't like to search a tutorial and pretty much copy that, because you do have to think about all these cases. And it's very iterative, so we're going to try this first version, and then start doing building on top of that, maybe to do all the forms. They seem simple at first, but then they are way more tricky. Yes, and people usually like say, oh, okay, just use a library for that, and they kind of miss the point, I think. The point is to kind of develop the skill to solve these kinds of problems. And they are everywhere, even though they may not be as math heavy as this one is, and in terms of hacking a solution together. But the development that you think about these problems are exactly how to get smarter, I think. Yeah. So let's totally do that. So I'm going to, if we collide, we're going to revert the dpy. Okay, so let's see if this is true. Okay. Okay, so we got what we needed. And yeah, that's pretty cool. Okay, now let's see if we enter from the side. Okay, now it should be wrong. Yes, it's wrong. But now we can test the other guys, right? If the old ball P, okay, let me draw. Okay, yeah, in this case, if the old P X was less than this guy, see, if the old is less than this guy, yeah, that's correct, revert. If the old ball Px it was greater than this guy, which is this guy, also revert the x, correct? And I'm going to do the same thing for y. So yeah, this is kind of a fake sweep. We should probably learn more about sweeps. I'll do that, and maybe in the next stream we can clean this up. I'm going to comment that, but I think we are going to be able to progress, at least, which is always good, right? That's the whole point. Okay, let's see what we have. Okay, that was correct. Okay, that was nice. Let's see. I think we are 100% in terms of a basic collision detection. Okay, we're not 100%. Wow, that was pretty bad. You know what I think happened? It collided with more than one block. Wow, that was, wow, that was pretty bad. Yeah. If the ball X was greater than the block, could it happen at the bottom of the block? I don't think so. Let me draw and see if the ball X was greater than the block X. In this case, it's the block X plus the half block X, right? Yeah. So if the old block X was greater than this guy, so in this case, he was here in the beginning of the frame, somewhere here. So in any case, even if he did that, well, I'm not sure. In this case, maybe yeah, he should just reflect in Y. Yeah, when he came from the bottom right, yeah, like this. Yes, in this case it would be wrong. You are correct, Morpheus. But in this case, should he always reflect like this? And can we get the same problem like this? We can probably do that like this, right? Yeah, I think we're gonna have to do some vector mathy stuff. Like, we can probably know like this. Well, we have these. We can have this vector, right? that doesn't tell us much. Or doesn't it? You will need to draw a line between the old. Yeah, we could do that. And then check where intersects with the block. Yeah, okay, so that's the full sweep you're talking about. So yeah, I think we're going to have to do the full sweep. And that's going to be cool because we're going to learn more, I guess. And it's going to be a little bit tricky. But I think you are correct. We are going to do a full sweep. So let me just explain what I mean by that. So if we have this guy and expect, and then check where it intersects. Yeah, exactly. So Morpheus, he got a point. The point is, we do have to draw this line from the old and the new. And we're going to check this guy. And then this guy, we can actually stop him and then reflect the position based off the rest of this guy. Because we'll know at this point. Correct? So the idea is kind of make a lerp. Lerp is a linear interpolate. Okay, so the lerp is, let's say we have this guy at the beginning, let's call it A, and this guy at the end, let's call it B. Lerp takes A, B, and a T, which, where do you want to go? If we go 0, we start at the A. If we go 1, we go to the B, okay? Okay. But what we want is the other way around. We don't have the T, correct? And we want to find that out. Okay, so this is starting to get a light at the end of the tunnel, right? So the lerp function is 1 minus t a plus b plus tb, right? So the idea is if we pass 0, we're going to be 1 minus 0 is 1, 1a plus 0 times b, 0. So we're going to get an a. If we pass 1, it's going to be 1 minus 1, 0. We're going to get full b. So this is the lerp. But we want to do the opposite of the lerp in order to get the sweep. Because we want to know this guy, and we should have the target, let's say, equals C, right? Okay. What we want to do, we have this guy, we have these guys. Do we have this guy? We do, right? I'm not sure. Let's just try to isolate T. Let's do that. Okay, so it's going to be A. Oh my god, I don't think I remember how to do that. 1 minus T times A is going to be A minus TA. I think that's correct. Plus TB. Let's just check. If it's 0, we should have A minus 0A. So yeah, if we have 1, A minus A. Okay, this is correct. Well, see, my high school math is not, oh, actually, like, even before high school, I'm not sure. Okay, so this is correct. And then if you isolate the, go to the, it says minus TA plus TB equals a minus A. Right, and then we can take the, we can write it like this, looking like TB minus TA equals minus A. We can do T times B minus A, correct, equals minus A. T equals minus A divided by B minus A. That looks a bit weird. I think, yeah, we should really use the C. So it's going to be C minus A. C minus A. Okay, now it looks kind of a little bit more correct. So the idea is, given an A, a B, and a C, which I'm not sure we're gonna easily get, we will be able to get the t, and the t is how much we should move in this direction, right? How much should we move in this direction to reach this guy? At this point, I'm thinking about cheating and kind of searching, because we've got to this point, which is a lot of progress, and I could cheat in my code base, or I could cheat on Google. I don't know which one's worse for our learning experience, or we could just keep doing that, because I think we got to an interesting point, but I think we're missing something. I'm not sure. I mean, in the C, how would you get the C? Yeah, I'm gonna cheat in my code base for now. Let's see, I have this game, and see, we have all these crazy collision detections. Line trace, yeah, it's called line trace. Line trace versus AABB. So we have the start and the end. Start and the end, so no C. And we have the object P and the object size. Okay? Okay. C, a point or the entire line? Yeah, the C, we're going to get C, which is this point, when we solve this function, right? So that's the thing. If we get the T, which is what we need, we will be able to find in what point he's intersecting, and at that point, we'll be able to know if it's this guy or the other way. So see, in this case, make it really clear. So the delta here is the line. Okay, so first thing, I'm going to draw that code example, because I already searched that and it's not very fun. It apparently didn't stick in my head in terms of math stuff. But yeah, I do have to flex those math muscles a little bit more. So we have this guy, object P, and object size, and we have A and B. And in this case, we might as well draw B out here because it'll work. That's great. That's a point of that we were talking later. So we can do the ball really, really fast in very small blocks, and that could be fun actually. Very small blocks, or not, because they're gonna kick all over the place. So who knows? Okay, so we first find out the delta, which is this line. Okay, I'm gonna call that D. Okay, in this case it separates, yeah, because the object might be going exactly sideways or exactly upwards and downwards. In this case, we can't divide by 0. So we have to change that. And the tx and ty, which is what we find here, tx and ty, is going to be object px, which is this guy, minus start x. Okay, so we find out this guy, divided by delta x. So C, object, yeah, we almost got it right. We almost got it right. So this is the function that we wrote here in the stream. And the divided by b minus a is correct. The b minus a is here, the end minus the start. That's delta. So that's correct. And minus a, that's also correct. But the C part, we got it wrong. Apparently, is the object P minus A. Does that make sense? The object Px, okay, we're testing the x. So we want to know Yeah, we want to know in X how much we can move. In this case, we can move up to here. Let's say this is 0.4. 0.5. Yeah, looks more like 0.4. Minus 0.4, right? No, it's actually 0.4. So the 0.4 is the object P, which is this guy. Let's say this guy. Minus the start X, which is going to give us this guy. Okay, now it makes sense. Okay, now it makes sense. We are correct saying that C, which is this point right here. See, this is where I'm sorry, is this point? Yeah, we are correct. Let's just try to understand that a little bit more. At this point, I think I'm going to do that 1D, just to be clear. Yeah, when you have a tough time in 2D, make it 1D. When you have tough time in 3D, make it 2D. That's kind of how it works. Okay, so let's say we want to go first from here to here. Okay? Okay. The object P, in this case Y, let's say this guy is 10. 10. This guy, let's say it's 8, and this guy, let's say it's 7. Okay, what we want to do is to know at which point do we hit this guy? See, that's the correct question. At which point do we reach this guy? And yeah, and this guy is the C in this equation. Yes, that's 100% correct. Okay, so after thinking about that for some time, I don't know how much time, but for some time, I think we got to a understanding of the problem. We are doing a sweep, which means that we're going to ask at which point do we collide with that line. If for some reason the point in this case is past the point that we want to go, we don't collide. If for some reason the point is after the point, like let's say this is 11, at this point we know we collide with this axis. That's why in this other code example we split the axes. So that makes sense. So yeah, I think I understand more about it now. Actually, I'm sure about that, but I think I understand enough that I can confidently write the code. Okay, so what we're going to get is a value that's going to tell us how much we have to move in this scale, which is this scale, which is AB, to reach C. In this case, it's going to tell us like 0.8, for instance, which is this guy. And in the other case, in this case, it will tell us 1.3. And if it's greater than 1, means that we didn't collide. If it's negative, we didn't collide either because it was on the other side. So I think now we are confident enough to write that. Okay. So let's do this. Do you guys understood the basic idea of the sweep we're going to do and how it's going to help us? Yeah, okay. Okay, so let's go. Collision. What I'm going to do here is I don't know how do I call it. I'm going to try this like a line trace. That's a pretty bad name. Line trace versus line maybe sweep for, yeah, sweep for AABB. That makes sense. So we're going to have a problem, which we'll fix. Yeah, not really, but let's see. Okay, yeah, we're going to have a problem, but we'll see. So the sweep's going to return an F32. That's going to say how much in this line we moved. Okay, so let's do this. The V2P, which is this guy. Let's say start. Yeah, start. V2 end. And then we're going to do like object P and object have size. Yeah, the problem, as you can see, is that we're only testing a point versus an object. So we're not really testing for the bounds of the ball. But we can easily fix that. But we're going to do that later on. First of all, let's try to do this version. So start, end, object P, object have size. Okay, so first of all, we have the difference. The difference is going to be the subtraction of the end and the start. So this guy gives us this guy. So in this case that we're doing 1D, I'm sorry, it's going to give us -1. Correct? Correct. And then we're going to do, and the difference is this guy. As you can see here. So the C is going to be the start. Correct? Yeah. So let's do for Y. So the start dot Y, that's the C, minus, I'm sorry, object dot Y. Object dot Y, we're talking about the red line. The object Y, which is 10 in this case, minus A, which is the start dot X, divided by A minus B, it's the diff dot X. We could make that explicit and minus start. I think I'll do that for now. Okay, so this supposedly gives us the T for Y. Okay, let's see. See, the problem is math. There's a missing formula here. People smarter than us have already thought about that for a long time and got to that. All you have to do is understand, really understand, so we can use that in our game. I think that's more important than try to come up with that, although we did manage to do that bit by ourselves. Okay, so what we're doing, in this case, object Y, 10. 10 minus start Y, 7, divided by 8 minus 1. In this case, we have 3. Yeah, that's precisely correct. And 3 is greater than 1, so we're not colliding. Perfect, actually. In this case, let's say this is 12. The end is 12, so it's going to be 3 divided by 11. No, I'm sorry, it's minus 7. So, yeah, no, it's 12. 12 minus 7. 12 minus 7, which is 5. In this case, it's going to be 0.6. So it's less than 1, so we are colliding. That's it. That's it. And in this case, let's say, in this case, which was the problem with the first version we did, we would not have this problem because we would first know that we collide in X, correct? Let's see, like this. Yeah, there's this part also comes into play, right? First, we have to know we are not in these bounds. No, I'm not sure. Let's try to implement this part only. Okay, so if ty is greater to or equal to 0, yeah, if this is 0, it's going to be a problem. So let's not try to think about that for now. We're going to try to divide by 0. And ty is less than or equal to 1. In this case, we do collide. So for now, all I'll do is do a return true, means I do collide, and I'm going to return false. Okay, then if 0 these guys off. Finally, some programming and not enough, and not thinking. We've been thinking for too long. I don't like to think that much. So I'm going to do a sweep for A, B, B, and if we do sweep, in this case, the sweep is only this part, right? It's only the X, pardon me, the Y. So we're going to do the block P, block half size, ball P, I'm sorry, ball P, and we should get a ball desired P. Desired P. Yeah. Okay, if we do that, if this guy, then we can reflect the X. I'm sorry, the Y. Okay, now we have to get these guys. So instead of saving the old ball P, I'm going to do like a ball desired P, and the desired P is going to be this. Makes sense? And I'm going to test the player wherever there's like ball P in this code, because it's like old. I'm going to do ball desired P. Okay. Okay. Oh no, actually, I don't think it's okay. Object. This is the object P. Object P.y. Ball desired P. Okay. So we don't need the ball half size for now. All we need is the ball desired P. Old ball P. I'm going to pass ball desired P. Okay. We should probably step into the debugger just to make sure. But I just want to see visually what happens. The ball is stuck. Oh, because we don't. Yeah, we have to set that to the desired P here. Ball P equals ball desired P. Okay. Yeah. Yeah, it's not. We're just figuring out what to do. Sorry, that shouldn't work really. Now this should work. Oh, it didn't work. Okay. Let's try setting breakpoints. It's gonna be hard to catch that breakpoint, but maybe we should do like. We should really cheat. We should do like, yeah. I'm gonna control the whole player. Player P. I'm gonna do player Y. Player P.y equals. Well, I'm gonna calculate this again because it's just for testing. So I can move the player around. Okay, and then the ball is gonna be static. Ball dpy. Okay. So now we can test the collision. Okay, so what we can do as just a starting point, we should have done that earlier, honestly, to get the more collision. We're gonna do like is colliding, and we're gonna set that to every frame. Oh, so yeah, I'm gonna set is colliding to false, and if we are colliding, is colliding true. And I'm going to draw the player in a different color. Okay, that did nothing else. Still did nothing. If it's colliding, are we not colliding? We were not colliding. Ball DP. Yeah, this is starting to get really messy. I might have to go a step way back. Well, just because you said we were almost done, we hit this big wall in the head, and we probably have to take a couple steps back to make sure that our collision system is okay. And that's the main point I think we can take away from this episode. The basic gameplay and the collision system. And then once we have a good collision system, we can pretty much easily do the rest. But so it's worth spending some time in this. So, okay. Yeah, because we do test if the ball is less than, that's why we're not testing. Okay, so I'm gonna remove this guy. Not the whole guy, this guy. Okay, so we weren't testing. Okay, whoa. That was unexpected. Okay, let me just remove all these guys. Okay, that's the only thing we need. So this collision detection system is working perfectly. But, just because I said it was working perfectly, it's not working perfectly. Oh, thank God we did that. There's a problem in our ABB versus ABB in the X. Yes. See? Oh, this may have caused so much problems. Okay. 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 So now we have the information that we are at least, this may have caused more problems. In fact, now that I think about it, no, forget about it. Let's continue doing this sweeping. Okay, so that's the first step we do. We know that we are colliding. Okay? Okay. Now the other question is, if we were not colliding last frame, what side did we collide with? Okay? Which is basically the sweep. Okay. So how are we going to do that? Yeah. Okay. In this case, the player is moving. So we're going to test the player desired P and the ball P. Okay? So the player has a desired P. This is getting really messy, but we're going to delete everything later. So we're just experimenting. We're learning more. That's the point. So this player P is actually a player desired P. Player desired P. Okay, I don't remember why we did this. New player X thing. Oh, to calculate the DP. Yeah, for now, let's just ignore that. Okay, so the player desired P is this guy. Okay. 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 That's the player desired P. So if we play, nothing is gonna. We won't be able to control the player anymore. Okay. The thing is, we're gonna try to collide with a ball, and get a P from that. Okay. So I'm going to do this in line, then we can extract a function out of it. It's going to be more organized. So v2 start is the, yeah, I'm going to calculate basically this. So the object P now is the ball P dot x, the start P is the player P, and I want to go to the desired player P, player desired P, and I'm the player P. Okay. Okay, if these are equal, I'm going to divide by 0, which is not good. I think it's going to crash. Void. Now this is, I'm going to set this colliding here to true. Okay. And if it's not colliding, I'm going to player P equals player desired P. Okay. So yeah, I think we are correct actually, because we are only testing Y. Remember that. So the point is, yeah, see, yes, this is working. Okay. But it's not perfect because we didn't take into account the ball size here. So it's going to be ball this piece of the ball minus the ball y, ball half size y, minus the player half size y. And now I think I'm going to have a more interesting result. Okay. Now this is interesting because we know we collided with this part, and we can really do like, see how we stop immediately in the collision. We can go all the way to the edge. We could do like this is the advantage. Player desired P dot y. It's going to be a lerp of player P ty and player desired P. Let's do a lerp really quickly here in the math. We already discussed that. So we have a clamp. We're going to do a inline F32 lerp. It's going to take A, take T, take B, and it's going to return 1 minus T times A plus T times B. Okay. From V, yeah, we're going to do just a Y for now. Okay, now we should have the nice effect. Yes, this is pretty cool. But we're stuck. So, yeah. So, but I hope you saw, even if I was super fast, I didn't get stuck with the mouse over here. with a space in between. And we know how much the space is. It's 1 minus ty. So we can easily make, let me just turn the light on here, it's starting to get dark. Opening the window, we can easily get the difference in that and advance that to the other side. And that's pretty cool. That's one thing we discussed here in the beginning. Okay. Okay. So what else do we need to do? Yeah, I'm not sure if we were supposed to get stuck or not. Yeah, I'm gonna debug that. The game's not opened, so I'm going to enter the simulate game here. Just push that to the side. Okay. And yeah, I'm gonna put a breakpoint here when I'm stuck. Okay, now it's a good time. Okay, let's move that a little bit forward. Okay. So the ball P40, ball half size. Okay, the player P is 37. The desired P is 2. Does that make sense? I guess that makes sense. Now I'm trying to go down. Yeah, okay. And the player P is yeah, minus 34. So I think the ty is going to be negative, minus 0. Okay, that was unexpected. I thought it was going to be negative. Let's see why it was minus 0. This whole guy was this. Okay, and the player P was exactly 0. So yeah, it's going to be 0 divided by... Yeah, maybe we should ignore 0. I think that's the point, yeah. And should we ignore 1 as well? Probably. 1 is like... No, 1 is actually touching, so I'm not going to ignore 1. I'm going to ignore 0. Okay, now it don't work at all. If it's greater than 0 and less than or equal to 1, we only changed this. Yeah, we do get a couple of green frames. I don't know if you guys can see that. Yeah, I'm gonna put a breakpoint here. Yeah. Okay. So apparently, let me see. Yes. So we did hit the breakpoint correctly, and the ty is 0.8. So we move the desired p to 0.8 to the equivalent. Okay, that looks good. And then set the p to the desired p. And the next frame, we don't hit because it's 0. Now I'm confused. No, okay. So at this point we're 0? I think if this guy is 0, we ignore this altogether. Yeah, maybe an interesting point, because we can't divide by 0. So this guy, I'm going to call that div. This guy is 0. But this should only be 0 if we're not moving, so not sure how that changes anything. Yeah, that doesn't really change anything. Let me try to set this colliding. Yeah. Okay, so this is working nicely. I think it's gonna be hard to make it stop. Like maybe I should just test like this. If if we are colliding, yeah, that sounds good. If we are colliding, and I'm going to use the player desired P. There have size. Okay, so if we are colliding, we then check where we are colliding to. And that, I think, makes more sense. Yeah. I think we are getting somewhere. Okay, so it says we are colliding. If we are colliding, player desired P, ball P. Yeah, this goes up. Okay. Now, the is colliding part goes out here. But now we should stop the movement. Okay. Yeah, the player P ends up being, okay, reasonable. But in the next frame, let's see, player P, 73.75. 73 minus 102. Yeah, because I moved the mouse. It's going to be a little bit hard to debug. Okay. Funny thing that it works on both sides. Oh yeah, yeah. Because, yeah, it doesn't really matter if it's positive or negative. That's pretty cool. Yeah. No, I'm getting wrong. We changed the color to down here. Okay, so we are getting progress, but not much though. So if we collide, we're gonna see how much we can go, right? We're gonna set the play desired py to this guy. Maybe now we should be like this. Okay. Yes, now I think this is correct. Or more correct, I guess. Yes, okay. Okay, so that was the missing ingredient. It doesn't work in the other way yet, because, yeah, this works, but this doesn't yet. Nice. Oh, this is pretty cool. This is pretty cool. Now, I shouldn't be able to go through. Correct? I shouldn't be able. If it's more than 0, that's when we are colliding. I don't think this is correct because right here it's like way more than 0. Like, let's see. Let's draw more stuff. Oh, I think we are getting there slowly, but we are. Okay. Let's say we were here and now we are here. Oh, because we failed this. Yeah, I really don't like the idea of having to test this first. But then we can't be 0 here for some reason. I have to understand that. Yeah, well, yeah, we can't go back. Because we are colliding, but we want to go down. Why can't we go down? Oh, because these guys, yeah, this guy is going to sum up to 0. It's going to be 0 divided by whatever. Now I want to find out by myself. Mm. If this guy is 0, what does that mean? That means that we are exactly on the point. And if we are, well, this shouldn't be equal to 0. And this shouldn't be equal to 1. If we are on the point, we're not colliding, I think. Yeah, well, now I'm stuck again. No, I think this is the more correct behavior. Yeah, I might go and learn about it. Yeah, let's do a little bit of learning. Yeah. I'm gonna go to the master. I don't remember what this is called. Let's say intersection. Line intersection collisions. Approaching this problem using ray intersections. Ray plane intersection. Combining the intersection of a point of a reflector. Yeah, that's pretty much it. Intersecting a ray with a rectangle. This is it. Yeah. Let me see if you guys can hear that. I can't hear that, so.
So here was our equation. Our t result, meaning the t along that, the percentage along the player delta vector that we would have to go to intersect a particular wall's x-coordinate at an x-coordinate. So a wall at an x-coordinate, remember, is a vertical wall, right?
I think that's what we got wrong. This is the... No player P. Yeah. I think I already saw the problem. This guy is the desired. This guy. And not the other one. Let's see. I'm sorry. Actually, I was wrong. Or was I? Yeah, no, we do have green things. So we set the player desired to the lerp. Yeah, let's continue. But yeah.
So at the x-coordinate of the wall we care about, right, we want to subtract whatever the player's x-coordinate is, and then we want to divide by whatever the delta x-coordinate is, so the x offset. That will give us the t at which we would arrive there. We then want to check the bounds of that thing. And in order to check the bounds of that thing, we then have to figure out where the other component would be, right? So where would the y be, right? Well, we know where the y would be. The y is just going to be that, on that vector. So we would have gotten, you know, where he started from. He did that. Somebody has been into the code there. I'm sure, obviously, it could not have, how dare they? Those people will, all right. So if it's in there, then this is actually valid. And if it's valid, then what we want to do is check that t-min. So we want to say if t is a closer collision, all we need to do, but there's a catch.
If t-min is more than t-result, is greater than t-result. Yeah, the t-min he's testing. The t-min is 1. So if it's less than 1, yeah. If it's less than 1, maybe we don't need to test this. Okay. Oh. Now that's weird. Okay. What? Yeah, I think I can only go forward. Yeah, I think that's the problem. Let's see. Going forward. No. I should probably have a way to print camel case. Yeah. Yeah, I don't like it either, but
I talked about it on the last stream. Don't know if you remember. What's missing here? Does anyone remember what's missing? Okay, so we're not in good shape. It's true. Just so we were all clear on it. So you'll notice that he is able to interpenetrate the wall now, and that's because we're only checking his one base point, right? This is a so you can see that we're going to do areas we can understand until we fix all the rest of this stuff.
okay, so this is the correct code. T-min. Yeah, so the T-min is how much he wants to move. He wants to move by 1, right? And if he can't move by 1, he will move by whatever he can. This test we don't care for now because we're going to ignore. Okay, so this is the test that we are doing, which is greater or equal to 0. And in this case 1. Yeah, 1. If 1 is greater to, yeah, so in this case it's doing less than or equal to 1. Same thing we are doing. Yeah, I think the problem is, no, I don't know what the problem is, because the desired P gets this guy. So even if the, okay, let's go back to the pile. I'm out for today. Yeah, I also have to think. I think I'll stream tomorrow morning here. About, I don't know, 14 hours from now, 14, 15, 16 hours from now. That's about it. So you can calculate whatever time it is there and add like 16. 16 sounds like a decent time. Yeah, for tomorrow. Hopefully, that's the plan. Hopefully, this will be working, the collision detection. So we can focus entirely on the gameplay. And as you saw, the gameplay is not that difficult. You know, the problem are understanding the basic ancient materials. So yeah, that's what I hope to do in this next few hours. So maybe this is going to be like a failed and tried attempt of doing that. But yeah. Yes, that's it. So thanks for coming. But hopefully, for the guys who are still watching, we'll be able to understand this together. We are getting close because you know, we came from like a no understanding at all to a pretty close understanding. The point is, this is the old, this is the new. Let's just imagine in one day, this is the new, this is the desired, let's put it that way. And we have a problem here, a block here. Okay, we are trying to go from this to this. The question is, where should we stop? Correct? And as far as we calculated, everything was correct. So at one point we did get pretty close, right? So T, yeah, I think I may go back a little bit. Yeah, I'm gonna go back to this point. Lerp. Yeah. Dot y. Dot y. Okay. So at this point, this is what we had. This is what we wanted, but we couldn't go back. So this is almost correct. Almost. But why can't we go back? It's because of this 0. That's what we realized. It's because we are, yeah, let's say that we are, this is the ball, this is our point. We are exactly here, and we're trying to go out. And this 0 means if we are exactly here, we are colliding. Okay? But if we don't test this 0, we go straight through. Because, see, we do have one collision. So if I put a breakpoint, here, we will stop the breakpoint. But next frame, I don't know if I'll be able to do that. I'm going to put a breakpoint here. Next frame, let's see. See? I'm still colliding. But I think this is going to be, yeah, this was 0. Let's see why. The desired P, PY was 49. That's where I want to go. I am at the 37. So the numbers look good. Why? But why is this guy 0? So it's going to be 40 minus all that stuff, minus 37. These guys are going to be 12. So I think we have a problem with our operations, I suppose. So these guys are 0. Ball P, oh, because the same problem? We are exactly where the ball is? Yeah, so it's the same problem. But since it's not 0, or I'm sorry, since it is 0, we're going straight through. So yeah, it doesn't solve the problem. The problem is, in this case, where we are colliding and we want to go out, we shouldn't really test this guy. We could hard code it, like if, well, let's calculate this guy. Let's call it diff again. Diff. If diff is negative, means that we are, yeah, means that we are going the other way. We shouldn't really block. Okay, I think we did the other way around. If it's positive. Yeah, if it's positive. We're going upwards. So if you are going upwards, we block. Okay! Yes! I think we finally understood it. This is beautiful. Right? Yeah, this is pretty cool. Yeah, and you have to test for the other dimensions as well. Okay, and it's a perfect slide. Okay, this is what we want. But if we didn't want to block and we just wanted to check collision, we could just do this, and we had a overlap event. Actually, we don't. Why is that? I set is colliding to true. Yeah. I don't know, but in this case, we're going to test. This is what we want. We want to block. Okay? Yeah, we want to block. Oops, we didn't block at that time. What did I do to not block? Maybe I started. Yeah, maybe I started up here. Let's try to start up here. Yeah, if I start up here. Now I'm blocked. Okay. Okay, so I hope you guys, you know, got something out of that, because it took a while, but now we are at the heart of it. So we have at the collision. Let me just have at collision. This is ABB versus ABB overlapping. Let's put it that way. But we're not going to use that. Let's just say overlapping. What we are going to do is a block. A block. And what do we want from the block? Well, let's go back to the original problem that we're trying to face. We have a block, and we have the ball. If the ball wants to go here, we want to put the ball here, And, well, we can pretty much just deflect the ball. Yeah, I think we can do that. Okay. So, now we're going to do some serious cleanup, guys. Prepare for some serious compression of the code. You know, I actually am going to go to the bathroom and get some more water. So, I'll be back in like 2 minutes. Okay, I'll be back in 2 minutes with water code, not code, we're going to code after, and we're going to clean this thing. And now that we got the heart of it, which is this part, we will finally be able to create our easy-to-use collision detection system. Okay, 2 minutes. Ah, agora está avançando. Tá. So the thing is, it takes a while to, get the first time running, but once we have a good solid function, our next games will be a lot easier. I mean, I could be cheating from the other game like I did a short amount of time there. Yeah, so we work a lot once, so that's good about programming. What I want to do now, actually, is to stuff out how I want to call the things I want to call. Right, so I'm going to probably break the game completely just to get it working in terms of a structure. So this is what I want to do, and now we are capable of doing this. Now I'm going to copy this guy, which is what we managed to get to working over here. And then we can start cleaning the game code, okay? Okay. So the initialization is working great. The player for now, I don't know if you need a desired P. Yeah, I think we'll do a desired P for the player and for the ball. Okay, yeah. Now, I think I can keep this for now, and maybe do more complete stuff later. Okay, because this was working pretty nicely. The problem was because we always know that if we hit the ball, we're going to bounce off the x-axis, we're going to bounce off the y-axis, and we're going to add our x velocity to the balls. So that's easy. The problem is the blocks. So, okay, it's colliding false. Okay, so this was working nicely. Clear screen. Okay, yes, this is what we wanted to fix. So let me just go back to running just to make sure. we're not working because we also have to do player P equals desired player P. And for now, we're not colliding. It's player desired P. We're not colliding with the player, but later we can do a. Oh, we also have to do only for the player desired P. Yeah, let's do player desired P. Y x equals this guy, and player desired P dot y equals player P dot y. Yeah, later we can block him in the wall and do some pretty cool stuff. Oh, it's still not working. Compile. Dot x. Okay. Yeah. Okay, so we're back to the point we were, and now let's just make the ball fall. Okay. Now we want to collide with these guys, and we may change the ball position, right? So this code that we took a while but got to create is the collision code for this guy. See? I can just put a comment here, giant comment. This is the ball block collision. Okay. We can remove. I think we can delete this function. This was like really bad. Yeah. Okay. Yeah. And this one we just copy that. Sweep. Delete. Okay. Nice. We can test like is colliding. It's a better name. Is colliding is true. AABB. I'm gonna call is colliding. Is colliding. Okay. Okay. Starting to get cleaner. So we're gonna do for the y, then the x, and then the. What we didn't do, but it's pretty easy, is that if we are colliding, we have to test the other bounds. Like we have to test if he isn't here. And this test is pretty much the same as this test. Okay, so if this and this, we should be good to go. But I have to rename all these guys, right? So this is not player desired P, this is ball desired P. And this is not player P, this is block P. Okay, diff. This is gonna get confusing. Yeah. The ball P, yeah, the ball is the block. So whenever I see ball, I'm going to change to block. And then I'm going to do like this. Block half size. Okay. Yeah, and this guy, it's the block P, block PX. This is the block half size. This is the desired. This is the ball desired PX. Is it the desired? Well, I think it doesn't matter really, because if we are like here, yeah, it's the desired. And if you do like a huge sweep, no, like this. Actually, this is problematic. Because if you do like this sweep, this guy, yeah, this is gonna enter here. Let's imagine in Y, so it's gonna hit and say, okay, this is a problem. Okay, yeah, I'm sorry. We are going to test where, if in this position, if it's colliding. Okay, now it makes sense. Yeah. So I'm going to get the the target x. Target x is going to be a lerp of the player. I'm sorry, we're doing the ball p. Yeah, the ball p dot x. And this is the ty. Okay, now it makes sense. And the ball p, and this ball desired p dot x. Okay, now we're good. And that's the target x. If the target x, just to make sure it's this point, right? So I'm gonna copy. I don't know why I closed. This is what we need. Target x. If the target x plus the ball half size dot x is greater than the block half size. Sorry, block p dot x, and this is the block p dot x. This is the block half size. Okay, I think we're getting somewhere. Player p. Yeah. Now instead of player, we have block. I'm sorry, ball. Ball. I'm gonna search player and change for ball. Okay, target x. We're gonna create that variable here. Okay. If you guys have any question about what we're doing, be free to ask them. But we're making a breakout game like this. And what we're trying to do, we've been trying for the past hour or a half or so, is to make collision with these guys in a proper way. I think I commented out. No, I didn't. Oh, I don't calculate the player DP anymore. Okay, player DP. Maybe player desired DP or less frames DP. Maybe less frames DT. So I'm gonna do like player DP equals player P, right? I'm gonna do just the X. It's gonna be the player PX, the desired minus the player PX. Yeah. So now we should be able to get the ball moving in the x-axis. I don't think we did. Oh, we didn't. Player P. Player desired P minus player P. Oh my god. This is just a small thing. We already did that just because we're trying to solve the other problem. But we commented out so much stuff that we broke this. That's typical, right? Let's see. Player, let's see, if the player is moving like this, the DP is the new one minus the old one. Yeah, that's correct. Player desired PX minus player PX. Well, let's see, why isn't that working? Let's see, it starts off here. Oh, I don't think we compiled, maybe that's the problem. Yeah, let's see. Oh, missed the ball. Okay. No, we still didn't work. Okay. So yeah, I'm gonna hard-codedly change the value of like desired P, just to get some movement. Desired P x, I'm going to put like 0. So the player dpx, it's pretty huge. This apparently is correct. If we go to the next frame and get the value of player dpx, where's that? Here. This is correct. Oh, we forgot. Yeah, we already talked about it. We forgot to divide that by the dt. Okay. So that was a very small number, but now it's correct. We already talked about that, but yeah, there you go. Okay. I don't think it's as we expected. It certainly isn't working. But well, let's see. Yeah, it's certainly not working. Let's just see what we're doing. Yeah, we can remove this guy. Yeah, I think that was the problem. Let's see. Okay. Okay, we got some behavior that was weird, but I'm not gonna complain too much. I think yeah, okay, no, this is correct. But we also have to change the direction of the ball dp dot y. Okay. Yeah, because it was two try. Yeah, I think that was expected and correct behavior, honestly. Yeah, now it's stuck because it's between two guys. But because we're not testing the x yet. Let's see. Oh, not working yet. And actually didn't change. The ball dp y. I'm gonna put a breakpoint there. I should probably do a stronger movement. Okay. Yeah. I see. So we collided with a block, and we are going up 30. Now we're going down. Actually, it didn't change anything. What? We're still going up by 30. Why is that? Okay, yeah. Sorry. I think someone caught that, probably. -1. Multiplying by 1 doesn't solve our problem. Actually, it does nothing. Okay. Okay, now we're talking. Yes. Okay. Yes. Okay, now I think we're gonna work. Wow. What was that? Let's try to win. Oh, I did win. Okay, now I lost. Okay. So this now is way better, right? So this is trying to move the ball. Yeah, we can probably start, doing a compression on this. But what we are going to do is, let's see, change y to this, change x to y, and change this to x. Diff redefinition. Yeah, okay. Okay. Let's see how's that working. Wow, I really suck. I really have to fix these controls. Okay, let's see. Okay. Okay. Let's see what's gonna do. Okay. Nice collision there. Let's see this side. Okay, this side didn't work. Yeah, I also think top isn't going to work. I think this is supposed to work. Oh, we're testing if diff is greater than 0. We should just check if diff is not 0. Yeah. let's see this side. Yeah, failed. Okay, what's that? Oh, that's not entirely bad. I mean, this is not what we want. Okay, this is entirely bad. Okay. Yeah, the diff means that it's not moving on that axis. So in this case, it's not moving up. If it's not moving up, there's no problem with not testing to change the up direction because it's not moving up. Maybe it's because of the epsilon. Like it's very close to 0, but not actually 0. I don't know. That was weird. If we do like, if it's greater than 0.001, or if diff is less than 0 minus 0.0001. Yeah, let's try and do that. Yeah, it's still weird. What is it doing? Okay. It is colliding though. So the problem is not it's that it's too specific. Maybe just put that inside these braces. Okay. That worked. Let's see. Yeah. Yeah, mouse is good because of that. You can really catch these guys. But it's hard to control this hand. So we're failing this case. You know what I should do? I should probably go back to the other case where the mouse was controlling. Oh, I can do the mouse controlling the ball. Too. Yeah. Nah. Just gonna try to fix that. Okay. Diff. Yeah, the diff is the problem because that's the thing. If it's going this way, the diff is gonna be, let's say, negative, right? Yeah, it's exactly. And we're testing if it's positive. But I don't know why when you test was different than 0, it glitched out. Let's just ignore this test and hope it doesn't explode. Just to see what's going on. Okay. See? I don't know why. We're not getting division by 0, that's for sure. Because it's moving like... This is really weird. If the diff is greater than 0, if we don't test that, we get collision even though we shouldn't. This is wrong. This is the... No, this is correct. Yeah, this is correct. I kind of got confused for a moment. Yeah, it's weirdly sliding, even though it wants to go to the other side. Yeah, I should probably go to the do the other test. We're spending a long time on this, but I think I'm getting more and more of the problem. So I don't see that as a problem necessarily. Yeah, I'm learning a lot. through all these weird physics stuff. Let's just see if this side is okay. Maybe we can hack and do it like the other side, kind of a same way but different. Yeah, let's try and do that. This works for one side. I'm sorry, this. Yeah, maybe that'll be the solution. What I'll do is if diff is less than 0, do this. See, the only difference would be I'll be testing if this was greater than 0 or less than 0, which is the same as not 0. So I don't know if this works. I don't know why this works, but I don't know why it wouldn't work either. We can go step by step. Yeah, because I think that's the only, I know, let's say side dependent. Yeah, see, it doesn't work. Oh, because it's doing both of them. I guess. Yeah, maybe it's because it's doing both of them. I just want to see if it's going to work on the other side. I think it's going to be the same thing on the other side as well. Yeah. What was that? Okay, let's see. Yeah, it went straight through. Didn't work at all. I think I'm gonna draw again. Let's see. Okay, so this is working. This is not working. Okay. Yeah. Let's see why this works first. But we know how it works. But let's just make sure. Let's do some values. Okay, let's say x, 10, 15, 20. Okay, easy enough. The diff is 10, which is this minus this. It is greater than 0. Yeah, oh, this is the problem. But we're trying to understand that, despite of that. We're going to do block. This is the block, 20. 20, yeah, we do all this minus to get this point, but let's assume we already got that. 20 minus 10, which is 10, divided by 10. This may be wrong. But we did pretty well. We did that correctly here in the stretch, yeah. Yeah, equals C. This is correct. C minus A. C minus A, so C is this guy, minus A. So it's 20 minus... I'm sorry, it's 15 minus 10. I don't know what I was thinking. 15 minus 10, it's 5. So 5, yeah, it's perfect. 5 divided by 10, 0.5. So we're going to go this far. Now let's do the other way around. And we'll kind of ignore this guy if we need to. So this is 20. I'm sorry, this is 10, 15, 20. Okay. The diff between the desired, which is 10, minus this guy is minus 10. Oh, I think I'm going to get the absolute value of this guy. Pretty sure. Minus 10, yeah, let's see. Minus 10. Because we're actually getting the vector. We're not getting, yeah, okay, let's see. Let's see. Minus 10 is the diff. Block, which is 15. 15 minus, let's see here, 15 minus 20. Is it correct? Yeah. 15 minus 20 minus 5. No, you were correct. Minus 5 divided by minus 10 is 0.5. It's not the absolute value. Now, I shouldn't really do that twice, but yeah, this thing, now let's see why it doesn't work. Maybe we can test with one block. I think I'm going to do that. Yeah, this is really bad. We went straight through. Yeah, it was exactly like this case, 10, 15, 20. We got as a diff. Okay, so 10, 10, 15, 20, we got minus 10 as the diff. Actually, we didn't get minus 10. I think that was the problem. We got 10, didn't we? It's the end, which is 10. Oh, no, yeah, 10 minus 20. Okay, minus 10. Minus 10 is the diff. This guy's 15. 15 minus 20. Okay, so this is 5. Yes! So I suppose this is the thing. I need the absolute value. Because we're talking about vector size here. Isn't that right? Or not? I don't think we're getting... Yeah. No, I don't think it's vector size per se. But it is... yes. In line, F32, F A, if A less than 0, return minus A, return A. Okay. Oh well. Oh, this is not good. I can test it's greater than 0. Who cares? Apparently, I think it's running twice. Why is it running twice, guys? No, that was very subtle. Let's see. That was very subtle too. Okay. That was a huge failure. Let me try to do one block. Okay, one block. I'm gonna do one block, and I'm gonna center the ball so that it collides directly. Okay, let's see. Ball px. Okay. See, we saw the problem. It's easier now to see the problem. Now, if we take out the absolute value, that's, yeah, the y guy here, it's just going to be ignored because the diff is negative. Now, if we place ourselves down here so that it goes back on us, it's gonna reflect properly. Okay. Why doesn't it work when the values are negative? That's the question. I thought I figured it out, but apparently I didn't. So the thing is, the diff is it's going to be, this is the desired, it's going to be 10 minus 20. The diff is minus 10, no doubt. This guy, okay, this is wrong. This is wrong. Okay, I think we got the problem. We can't subtract, because if we do subtract, we're going to find this guy. And then it's going to apply twice. Okay, now it makes sense. Good, 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 good. Okay. See, we should be positive, plus, but only if we are on this side. We could hack that. Like, if we are on the other side. I think that should be the best case, really. Yeah, I'm gonna do it. I'm gonna do like, I'm gonna do a collision point equals this guy. And maybe I'm gonna try to do that on vector later on. Collision point. Well, I don't think. Yeah, forget about that. Who cares? Let me just get it working first. If the block P is greater than block P. If the block P is greater than the, is it the desired P or the target P? I think I'm just going to look at the DP. So this is the ball DP. Yeah. So the ball DP Y. If it's going up, it's working. So if this greater than 0, the collision point should be this. Else the collision point should be plus. Hey, what's up, Dandy McG? How are you doing? We're solving some collision problems. You've got to you arrived at a great point, honestly, because we are about to solve the collision problem, and we spent a long time on this problem, but it's gonna be great. Well, actually, we didn't do anything. Let's see. Okay, no, I think we can go back to this guy that we were experimenting. Yes, let's see. I did spell it wrong. Yeah, I did. Thanks. No, but it's nice to be organized in this sense, you know. Okay, finally! We finally managed to do this. I think you brought good luck. I think the problem was the comment was spelled wrong. That's the problem, because the compiler compiles the comment and it realized that it was wrong. Yes, it is breakout we're doing. Let me show you. Now we can do a lot of cool stuff now that we can have collision working. We also have to clean this up because it's a mess. We also have to do that for the X collision. I'm going to do this really quickly. I'm going to change Y for X, and this is going to be the collision point. Collision point. Okay. Yes, we need a lot of things, actually. The game is super boring, but I hope in the end it's going to be very cool. Let's see. Let's see if it collides properly. Okay, collides. Okay. I did watch that talk. I couldn't find it after I watched it, but I do remember that. If you have the link, I'd love to watch that again, because that was like super over the top in the good sense of the over the top aspect of it. But I couldn't find it. Yeah, but Art of Screen Shake is about the shooter, is it not? That's I don't remember he having breakout here. Or you're not talking about breakout? Yeah, this lecture is about the shooter, right? Yes. It's a great lecture, but there was a breakout one, and I couldn't remember who gave that. I thought it was JW from I thought it was the guys from Blumbeer, but I couldn't find it after, and it was even more over the top than his shooter. It started out as a super boring breakout game, pretty much like this one we're doing, but at the end it was like crazy stuff going on. There was music, and there was all sorts of lighting effects. That was pretty cool. But I couldn't find it again after I did. But it's on my mind, and I want to make this game super cool to play. And if you check out our, let's say, the benchmark, which was the other game I released, let me find it, h.io, h.io, let's see, zaydan.h.io. Yeah, so this Pong I created. Oh, I think you did find it. Let's see. This Pong, that was pretty cool. Check out the video. I think it's pretty small. Yeah, you should download the game. It's pretty cool. It has all sorts of Yes, that's the breakout lecture. Let me just put it over here. Wow, thanks a lot. I definitely going to watch that again. That was a very fun thing, and I really played. Yeah, I tried the game here. Yes, you could play the game. Yeah. So that was over the top, like a lot over the top, but you could really learn a lot through that. Use it or lose it. Yeah, nice one, man. Thanks. So I guess you have a reference for the breakout game. No, it's not going to be that over the top, but it's going to be definitely fun, and it's going to be hard to program this kind of stuff. But we're certainly gonna do our best. It's gonna be great. Wow, thanks, man, for trying to get. Did you ever play Plasma Pong before? No, I didn't play before they got sued. Was that a super exciting Pong like that breakout that you showed? That's pretty cool. Wow, thanks. So, but at this point, we are super boring, right? We are like pretty much the boringest version. Yeah, I will look up on YouTube later. Thanks. We're pretty much super boring, and actually we're not even winning, but it's pretty easy at this point to make the block disappear. All we have to do is to set the block active, block life, minus, and everyone has 1 life point in the start. So now we should be able to destroy blocks. It was Pong with fluid dynamics. What? I gotta check this out. Okay, so now we can destroy the blocks. Okay. Here's my playlist if you want. Yeah, I'm definitely gonna check that out. Lots of good stuff. I'm certainly gonna check out. Okay, now we're starting to have a breakout game. Wow, that was worth it. You know, that whole collision problems we had. That was problematic, but wow, I'm super glad that we did fix it. I think I'm gonna have a hard time getting the ball behind all these guys. Oh, I almost did at that time. Let's see. Okay, let's see. Okay, yeah. Now it's starting to get starting to become a nice breakout game. What we could do now is we could do more like gameplay stuff in terms of like placing the blocks in the correct place and things like that, or we can go a little bit of a game feel movement since it got inspired, and it's pretty easy too. Yeah, I think we should do just the basic of animation on the mouse cursor. I think that's gonna be fun. Okay, now we're talking. Okay. I'm just getting the position and adding so I can get really fast on the x-axis. Okay, now I lost. Okay. I make a breakout long time ago, and my professor liked it so much she asked if she could use a tutorial for her intro to programming. That's awesome, dude. And I really think intro to programming stuff should be games, and I'd love to do an intro to programming class sometime. I'm getting more experience as doing this is my second ever live stream, so yeah, I'm still struggling. I'm live streaming for 3.5 hours. and I struggled a lot to get this working, but I did it, and I think that's important. So yeah, games are a great way to get started programming. So once I get used to the whole streaming thing, I think it's gonna be a lot of fun if I get to do that. Okay, I'm definitely gonna save your playlist because I think I'm gonna enjoy watching that a lot. And it's also gonna be a lot of reference, so we can do our. Oh, your name's Dan, Dan D McGee. Nice to meet you, Dan. Uh, it's great to it's great also to have contact with other breakout games like the one from the lecture. If I can get to play it here, I think it's gonna be fun. Let's see. I may have closed it. Yeah, let me get the link again. Okay. Okay, let's try the game here. And yes, I don't think I have a Flash player. Yeah, maybe I can do that on Internet Explorer. That's web games. Unfortunately, web games have this problem where the spec changes all the time, and the games get okay. So press tab 2 to reset. Enter enables all effects. Okay, let's enable effects. Okay, yeah, wow. This is great. You know, this thing about squashing and stretching the guy, that's a great feel thing to do. And I'm certainly going to do that. I did that on my game. I love how you don't lose through miss. Yeah! It's a feel-good game, right? Yeah, you don't lose. Wow, but screen shake is really cool. The ball also has a great animation to it. And the walls, wow, that's super cool. However, I'm not sure how you can control the dude. Like, if I don't move, it just reflects, right? Yeah. But if I move, can I actually control it like this? Yeah, I can. Yeah, it's hard to yeah, the best game feels invincibility. Only if you find out, right? Or only if you don't find out, I should say. So see, it's hard to control this kind of stuff with a mouse because I wanted the ball. Yeah, in this case it worked. But at that point, let's say I wanted to speed up the ball. The ball has a max speed. We should probably add that too. But yeah, see, I wanted to go that way and I couldn't. It has 45 degrees. Yeah, it's supposed to be a casual breakout exactly, but it's hard even if you let loose. It's going to be sad to compare that with our game now because we're so early in the development. But if we do this freedom stuff, it's hard to get it 100% precise. See, let me just hack it a little bit. I'm gonna make it less fewer columns in Y. Let's do 8, and yeah, let's just see if now it's easier to get the ball to that point L. And let's just add a little bit of Y offset. Let's do 35. Okay. Oh, I'm sorry. I should be able to do 15. Okay. Okay. Yeah, now it's a little bit too easy, I suppose. Yeah. But this is kind of interesting. Wow. See, that's an unintended side effect of just adding the speed, and you could probably just do that and pretty much be invincible because you're moving so fast that it's pretty much likely that at one frame you're gonna hit the ball. Wow. Okay, that was really weird. See, it's hard because it's all about, it's not about physics. It's all about, even though the physics is incorrect, I should say, but even if you do correct physics, it's not about physics. It's about what's going to feel nice for the player in terms of expectation and in terms of experience. Yeah, but it's hard to know exactly. That's one point I want to get more experience doing these small games. It's hard to get good at making it feel good, I suppose. I'm not sure how you feel about that. I don't know if your breakout game was had a great feel. I think I got a nice feel in Pong, but that was used, you controlled with the arrow keys, and let me show you the final project, because I think that was pretty cool. There was music and there was a nice feel to it. I changed the color based on the, let me see, releases. Yeah. Okay, I have this guy on. Okay, I'm gonna close that. Okay. Yeah, that. Oh, I remember if your game had sound. So, see how I apply the squashing and stretching, and also changed the color. And I think I got the acceleration and deceleration to a very nice balance. And I don't know if you're gonna hear. I'm gonna turn the volume up. Pay attention to the sound it makes when I move him. Could you hear that? That was like a sound wave that sine wave that I changed the length of based upon your speed, the length and the volume. So it has this whoop kind of sound, and that turned out pretty cool. And the goal of the Pong is that you control both pedals, and you can't let the goal be scored. So, yeah, see, and I also like the way I reflected the ball on that game. But the problem is, now we're doing it with the mouse, right? And the mouse has different problems. Because you can't do acceleration deceleration, because that's that's up to the player in terms of what he controls with the hand, right? So if you stop, you have to do it like a hard stop, and it's also hard to get the correct speed movement like this. See? Yeah. Maybe I should just play with that a little bit before I finish organizing the collision things we worked on, and maybe call it a day, because I'm kind of getting tired. Yeah, maybe we should just study some references too, like more breakout games. See, because this game, the way it is right now, it's easier to win by doing this and getting a lot of points horizontally. Yeah, like that. Than by the actual strategy of oh, that's pretty cool. I think I'm gonna win for the first time. Okay, or not. Let's see. Wow, that's super fast. And just for the record, it only works like that because we did our collision. I'm probably gonna lose now. Yeah, the ball is so fast that we certainly hit that. We certainly hit that every frame. That's really strange. But the point is, we managed to do that based on our sweep collision thing that we worked really hard on today. Which the point was, we know for a fact if it collides, so we don't suffer from tunneling, which most engines do. But we wanted to do a more I say specific thing for our problem. So that was it. That was the main collision thing. Okay, but yeah, I think I'm gonna call it a day. And tomorrow, I'm just gonna do some small cleanups. But tomorrow, I'm gonna start focusing on making the gameplay more interesting. Like I'm gonna focus on game feel. I'm gonna focus on the block's position, and gonna tweak. Yeah, or maybe later today. It's too early. Yeah, it's like 7 p.m. here. Maybe I'll do it like in an hour or something like that. Just need to eat something. Get some rest. Been streaming for 3 hours and 40 minutes. So yeah, I definitely want to do a more gameplay exploration thing where I get the breakout more fun to play, and that tweaks this thing, which is the multiplier from the X velocity and things like that. Tweaking that, and also tweaking the making a game win condition, and making it not the the exploitation of the game to do this. Although this is kind of fun, to be honest. Yeah, I lost, but I don't know why I lost. I was trying to do as best as I could. Let's try this one more time. Yeah. Oh yeah. Okay. And if you manage to implement that squash and stretch really quickly, I should actually do that just for fun. This would be pretty cool because I would pretty much occupy the whole space, right? But it also make the game even more exploitable. So I don't know if you want to do that. Okay, but that was great. If we start out, if we show, in fact, I think I'm going to do that. We started out today, which was 3 hours and 40 minutes ago. We started out with this. Let me show you guys. We started out. I'm going to SVN just to revert the executable. We started out with this. That's it. We only had this when it started out today. And now, we don't have this. We compile it. Now we have this, which should I say is a lot better. And actually, I can even just do a quick fun thing. I can make the colors even more, change even more, maybe a little bit more, based upon the position. So we have a nicer gradient. Yeah, that's the point, because I spent a lot of time in this collision thing, but when you look at the grand scheme of things, it's really not that long a time. It was like 3 hours to get this working, and like 2.5 hours to get the other thing working. Now we do need to get the gameplay to a nice stage. That's for sure. Maybe I should just add to a little bit more of a, I'm sorry, not player, ball speed, just to make it more challenging. Okay, okay, now I think it's gonna be a lot more fun. Yeah, okay. Now if I probably get a crazy X movement going on, I should probably, I probably fail, because now the ball is really fast. Let's see. Oh no, I didn't fail. I guess the same thing. And then I compensated, I hit in the other side, okay. Yeah, let's add more blocks in the X. Maybe a little bit more on the Y too, like 20 blocks. We should make a nice color palette and randomly picking it. Yeah, I should probably do that. Actually, okay, so it ended up hitting the... We could also fix that bug. We do have a problem with our rendering, I think, in terms of making things center. See how it's not centered? But it should be, based on our calculations. Yeah, you said about picking a color palette and picking random colors. Definitely, I think we're definitely going to be striving for a nice looking and nice feeling game. So yeah, yeah. Now it's a more breakout kind of game, right? And if I limit, I think I'm going to limit just for the sake of it. If I limit the x velocity of the ball, I think we're already going to have a somewhat interesting game. To the whole top, yeah. Because I move just a little bit like that. Yeah, actually, the less I move, I think the more it's gonna remove the guys. Let's try and move just a little bit. Just now, I think I'm moving a little. Yeah, let's see. Okay, a little bit more. Okay, I'm totally failing at this. Yeah. Let me see. You send your breakout game. Is that an executable? I can play now just for fun, or do I have to build? Oh, there is an executable. Okay. Yeah, I'm gonna do that. Download it. That's it. Oh, this is not the source code. This is actually the. Oh, it is the source code too. Cool. Okay. Yeah, it's okay. Saying it's from a long time ago and the directory is a mess. Yeah, the way I'm structuring this project is code and build. I like code more than src for source because I don't know why I try to type scr all the time, and yeah, it's not as intuitive, I think. Extract files. Let's do this. Breakout. Where did that? Okay, yeah. Okay. Oh, it's full screen. I think I'm gonna have to change the OBS settings here. Just a second, because it's not. I don't prepare it for full screen. And yeah. Just wait a second. Just make sure to see the full screen thing. Gonna add a display capture. Okay. Okay. No, it's not. It's not full screen. It's not even full screen yet. I'm having a hard time setting this up. Okay. Okay, now we're gonna do a full screen video. Okay. That was a big failure, I think. Let's now try to play the game. Yeah, I think a lot. Yeah, it's pretty. That's the thing about mouse. You know, it's hard. Let me just change my sensibility here. Oh, I can't. Yeah, let me make it yeah, less sensible. It's hard, you know. It's hard getting the right feel in terms of responsiveness and in terms of like yeah, things like that. You want to make the player want to control the ball all the time. But see, small things like that is hard because maybe it didn't actually collide, but you wanted it to. I don't know. That's the hard balance to strike. Okay, yeah, I almost got the ball there. Okay, yeah, yeah. Your breakout is pretty cool. It's pretty similar to the older breakout. You know, the original one. Yeah, pretty cool, man. Congrats. There's no like life limit, is there? I can pretty much die all the time, right? Okay, now I think the font's a bit too small for me. Uh, hmm. Yeah, it's 1800 by 600. Yeah, it's 800 by 600. Welcome to what? That was 2009. That's pretty cool, man. The angle is based on where you hit on the pedal. Yeah, you know, I think that's also a good metric. I like them both. I like making it based upon where you hit on the pedal and the acceleration. The pedal has constant acceleration. Might feel better with the slide video smoothing. Uh, does it have a constant acceleration? Let me try to open it here. I just felt like yeah. No, I control pretty much the yeah. I feel like I'm in control like 100%. Like if I move a little bit, if I move like a lot. Yeah. Oh, okay. Yeah. Now I see the point about making it a. And do you know if the original breakout game was only based upon the pedal position, or if there was actual acceleration involved? Because who knows? Maybe we can just do like one or the other. Yeah. By constant I mean infinite. Yeah, infinite, definitely. The problem with infinite acceleration is not that it's infinite acceleration. The problem is that if you add that to the ball, which is what I'm doing right now, that becomes problematic, and you don't want to do that if there's no acceleration. But it's really easy for us to cap that. So in fact, let's do it here. Let's do exactly this guy, but let's clamp it. I'm gonna clamp, let's say, I don't know, minus 100 and 100. And let's see how that feels. Yeah, now my mouse is not very much sensitive. Yeah, I think that's way better. Yeah. Yes, now I'm talking about, yeah, now it's nice. No input lag, no smoothing. Yeah, you definitely don't want smoothing on the mouse. That's the problem, because on the keyboard, smoothing feels nice, right? But mouse also already has like real life smoothing, I suppose, if you could call it that. Yeah, okay, now it's getting more interesting just by limiting that. Okay, now it's pretty cool. Most games have a bit of input smoothing, especially on the mouse. Yeah, most AAAs do, because it usually looks better. Yeah, okay, I think I'm gonna get that. I should get that closer on top, I suppose. What I want to do is I want to fix that position problem where I'm not actually centered. This should not, I don't know, since we already spent a lot of time debugging things today, we might as well do that. That should be easy to fix. Yeah, but I'm not sure about that. Let me show you the code that's driving it. Everything is software rendering for now. I go, each pixel individually, right? This is the rect draw in pixels, right? So if I create a rectangle here, let me just create like a draw rect in pixels. If I do a rectangle 50, 50, 150, 150, let's do it like a pink. This rectangle, it's gonna look weird, I think. Yeah, see? It's not actually correct. I believe, yeah, the point is, let me just show you exactly what I mean. This, I expect to be, I expect this rectangle to be somewhat like here. See, I set 50-50, so I expected the same number of pixels down here as well. So yeah, this is what I expected. I think that's the problem. But why is the offset? I strongly believe, is because the way we're getting the window size, we are considering this. So let me just do some print screen things. Okay, this is the window. Okay, this is the window. If I see the size of the whole thing, actually, if I just see the size of the drawable area, this area, it's 1580 by, yeah, because we are asking for a, you know what? I think I'm gonna, because this, I have like scaling turned on. We need to get, like, yeah, but I am getting the client rect. That's the problem. No, I'm getting window rect. You are correct. Wow, nice call, man. Get client rect. So yeah, so I had my suspicions that was the problem. So you were right. It's easy to, yeah, get wrecked. Dude, that's it. Oh, now it's way better in terms of correctness of position. So yeah, it's interesting because in the mouse we did do the right thing in the mouse. We did the let's see, pointer. Yeah, we do the screen to rect, screen to client. Yeah, so we did screen to client on the mouse, but on the screen side we didn't. We did get window rect. Wow, man, thanks a lot. Yeah, that was great. In the beginning of the stream, I did spend a little time thinking about that, but I quickly like, okay, maybe a little bit of a Windows thing and kind of ignored it. But yeah, now I certainly gonna keep that in mind. And I see that problem again. Easy peasy indeed. Let me ask you something. You were doing this kind of games in 2009. What are you doing now, man? Sometimes stuff like that takes 8 hours to fix. You're totally correct. And although what we did today wasn't exactly like that, it was more of a math exploration thing on the collision. So I think it was justified spending the amount of time we did. But yeah, it's usually you could do quicker things, faster things than you do sometimes. But yeah, if you're doing like that kind of game in 2008, dude, in 2008 I was playing like GTA 4 for 10 hours a day. Yeah, man. Yeah, I think we got to. Oh, let me just remove the draw rect. See, that's why building an engine is so cool. It gets better and better. So for the next game, you're not going to have all these collision problems and gameplay problems and things like that. Okay, now you're going to start. Now it's looking nice. Really nice, man. Yeah. You know what? Just for the fun of it, I'm going to implement the lose condition. And I might as well, add the difference in the size. Yeah. Okay, yeah. That's nice. Yeah, no, I'm gonna let the I'm gonna do that tomorrow. It gives gives easier things to do in the beginning of the stream tomorrow. Let's see. Twitch just gave me a blank page, so I can't see chat anymore. Wow, that was great. Thanks, Twitch. But wow, you're doing some 3D craziness with collision detection. I can see the minimap here. Oh, that's pretty cool. Is that a custom engine? I think it looks like a custom engine to me. Pretty smooth lines, things like that. Looks great. Very beautiful. I'm going to try to get chat back online. For some reason, Twitch decided to give me just a blank page. Twitch. Okay, now I can see the chat, but I lost the previous chat. Let's see if I can get... Yeah, in this browser I can't open Twitch. The browser... Oh, I'm logged in. Okay, yeah, OpenGL collision detection. Yeah, I think now I can go to the channel. Yeah. Creator dashboard live. Okay. But I think I lost the chat, dude. Come on, Twitch. Yeah, and soft shadows. Okay, lighting. Yeah, you were showing that. Let me show you. That's pretty cool, man. I really want to go more in depth on these kind of stuff too. But I'm I started with the basics just to get really solid foundations. Yeah, pretty cool lighting stuff, man. Yeah, awesome. Awesome. See, I got a blank screen from Twitch again. I must be doing something wrong. See how all the browser screens are now blank for some reason? Dude, what is going on? Well, maybe a good time to stop since that's going on. But dude, really congrats, man. You're doing some awesome work, and I hope to get to your level in terms of rendering and collision and stuff soon. I hope. Yeah, I don't think I'll be able to see the chat anymore because I really can't open Twitch. Let's see if I can open again on this browser. Yeah, now it works. Yeah, now it works. Okay, so I think I'm gonna close off. It was great talking to you guys. I had a really fun stream. It was a 4-hour stream. We got a lot done. what I am going to do now, if I'm able to show you guys my browsers. Oh my god, what happened? Opera, what do you expect? Come on, man. It's the best browser, but it's not much because, you know, browsers. I started in 2016 to load OpenGL and C. Yeah, I also started a short time ago, you know, and I'm surprised, you know, how much you can progress if you really dedicate, and I'm really happy. You know, I've been doing this kind of a small kinds of game in C for like less than a year, honestly. What I am going to show you guys is where I'm gonna publish the source code for today. So if you wanna play around with it, you can go to itch.io. You can go to danzaydan.itch.io and check out this Break Arcade Games out. And I'm going to post the episode 2 source code, which was today. And we managed to do a little bit. I expected to do more, but that's the thing. When you expect to do a lot of stuff, you usually don't. So you can't have like high expectations in terms of programming, because you never know. Maybe you get stuck on a problem for a long time. So yeah, and if you want to see the recording, in case you didn't see the whole live stream, or you want to see me, you know, painfully try to get the collision correct until I finally get the collision correct, you can go to my YouTube channel. It's www.youtube.com/danzaydan, and I'm gonna post the 4-hour video now. It's gonna take a while, but yeah, that's it. Thank you guys for watching, and I hope you enjoyed. And tomorrow, I think like 12 hours from now, maybe 12 or 14 hours from now, I'm going to do another live stream where we're going to advance the gameplay. We're going to make it feel nice based upon the great references that Dan showed and other references too. So yeah, hopefully you're going to tune in for that. So I'll see you guys later. Thanks.